All right, today we're going to be looking into some pretty interesting Flutter concepts. We're going to be building a basic card game. However, what I'm trying to do here is kind of show a bunch of different aspects of really any application that you might build in Flutter. So there's different things that we could have done. I could have decided to do differently, such as handling the cards completely locally. But instead, we're going to use an API called Deck of Cards API, so we can get some experience with working with asynchronous requests. And we're going to be building it in a way so that we kind of make a generic, really basic card game, and then override certain things through inheritance, so that we can have actually different games all sort of powered by the same core engine. So that's kind of what we're after. And this is sort of a preview of what something like what we're going to be building. Essentially, right now it's configured to work as a Crazy Eights game. So essentially, I have the option to, I need to either play a club or a number that is the same. And for instance, some cards have special abilities like twos, meaning the other person has to pick up two. So here I have to choose a heart. I can choose this. And oh, so he's chosen it to be spades now. So I actually can't play a club. I actually have to draw one and end my turn, et cetera, et cetera. So that's kind of what we're looking to build, and excited to get started into it. So let's do it. Um, we're just gonna literally start this from scratch. So I have Flutter up to date, and I can just go Flutter create, and we'll just call it cards. Actually, we'll just call it card game. Um, Card game. So it's just going to go in and make our stuff here. And if we go into card game, and we can open in VS Code. Okay, so this is a completely empty new project. I'm just going to close this guy since we're starting from scratch now. And let's get right to it. So now, because it's Flutter, we could obviously build to iOS, we could build to web. I'm actually going to be working building to Mac just because it's faster than compiling an iOS app. And as much as web is great, the live reload isn't as wonderful. A lot of times, even when I'm building stuff for Flutter web, I actually build it in a lot of the time in Mac, and I make sure I consistently keep testing in web because sometimes you install a package that causes issues, but it is to me the best way. In fact, sometimes with iOS, unless you're doing something that requires an iOS library, it's sometimes better even just to build for Mac and just kind of make the aspect ratio similar to a phone. It's just quicker. But if you are doing that, just make sure you're consistently testing in your actual target platform. So we have Mac OS set down here, meaning I can just essentially click run here. I just did the shortcut of Control F5 as it is my muscle memory. So I'll wait a minute and get going. So I'm trying to aim this tutorial at semi-beginners of Flutter. I'm not teaching the basics of Dart or the very basics of Flutter, but I'll try and as we go through this kind of scope things and give some context. So here we go. This is the built-in default thing that comes when you start a new Flutter project. Just some awesome counting thing. So what we'll do, I'm just going to make this a little bit just so we'll be able to kind of see this. We'll put this guy up here and just like that. And I'm going to zoom this a bit for people at home to be able to see better. Okay, very first things I like to do is just empty out some of this stuff that we know. Don't even need this home page, so we're going to kill that. And obviously now this is going to break, so let's just put just for now, just a scaffold here, and we'll give it just a body of text saying hello. Awesome. Now, if we are to refresh, we should see that. There we go. We got our hello guy. Everything's good. Okay, so we have our very basic, app started out here. What are some other things we might want to do in this app? let's of course just make this say something better, like card game. And most importantly, you'll see there's this little debug thing that shows up here, which just kind of signals that you're, running in a development version of it. It's not the actual release one. I just like to disable that. You can just do debug check, debug show checked banner mode and set that to false, and all of a sudden that guy's gone. So that's super nice. Okay. All right, so let's get some other sort of boilerplate stuff out of the way and figure out where to go from here. So in my lib, I'm going to make some new folders. I like to have a folder called screens. I might have another folder, and I can do it this way, obviously, but I do like to use terminal whenever I can. So I can go into my lib folder, cd lib, and I can actually make a few directories at a time. So I'm going to make a new directory called models. With make directory, you can actually make multiple just by having a space and say, what else might we want? Services, providers. There'll probably be some others, but those are the ones that come to mind right now. So let's start with screens. And we are going to just make our game screen, which I will go ahead here and just call it game screen.dart. This will be a pretty simple widget. At least at first. All it's really going to do is sort of build that sort of app bar and eventually incorporate the actual game board, as we'll call it. So let's make a stateless widget, and we'll call it game screen. And if we use command control space beside any of these things that are giving us these errors, it's going to kind of prompt us to import it. And because we are importing material by doing that, all the other things that we didn't like are all of a sudden happening. So let's make this a scaffold instead, and we're going to give it a title, or sorry, we're going to give it an app bar, and the app bar will have a title called game, or let's just say card game. And I realized this isn't just a string, it is a text widget. So we have that. And let's have some actions in our app bar. So within our app bar, we want to have some actions. And we're going to just have a text button. And we won't worry about what it does yet, but we'll get it. And it will have a child of text. And the text will say new game. This is how you would create a new game. And you'll notice, so if I do save this, and we obviously have to go back here and say, instead of using the scaffold, we're actually going to use game screen. You're going to see the button's actually there, and you can tell on Mac because you get the little thing. But unfortunately, the color of it is your primary color, which is the same color here. So let's just style it, text style, color, and we'll just use colors.white, and everything's good. So then we have a new game. Doesn't do anything, but we're there. Now you'll see, and this has been fairly new in VS Code with a newer version of Dart. There's a lot more sort of like IntelliSense happening, which I'm really, really digging. So for instance, this warning you're going to see a lot more now if you are up to date. Prefer with constant constructors. So you could decide like, you know what, I don't care about that, and you can, ignore it for the line or the entire file, but we should care about that because these are things that can really make your app more efficient when it's rebuilding every time. If it knows it's a constant, it knows it never has to rebuild, this. So we're just going to put a constant in front of here. Now, if we ever wanted to make card game this dynamic title based on some other user setting, like it wouldn't be able to be a constant, but it will be a constant, and this too. And if we go back to our main, we will also see that it's suggesting we put a const here. And I'm just going to put a comma here. I like to, most of the time, have trailing commas so that everything lines up really nicely. There we go. We have a card game. Off to the races. Okay, so let's, within our card game, I realized one more folder that I always have is a components folder. So just to kind of talk through these things, components are like usually widgets, so, things that could be embedded within a screen, whereas screens is something that takes up an entire screen. These are just, conventions that I like. Models are where we're going to have anything to do with data, things that are going to come from an API and become something we can work with. And then we have providers and services. To me, services are usually for like an external thing, so calling an API. And providers are things that kind of manage state and just different aspects about your app. So within components, we will make a new file, and we will call it gameboard.dart. And we'll make it another stateless widget, gameboard. And once again, we will import this guy. Okay, so within our game board, we'll obviously be putting, this is kind of where the main UI of our app will be. And for now, let's just put center, and let's just put a child of text saying game board. And I'm not going to worry about refactoring that because this is just temporary anyways. So if we go back to our game screen, we can go in, so we did the app bar, but we can also do a body. And the body will be of type game board. And this one, let's actually put a const in front of it for now. So there we go, we got our game board. It's centered because we did that lovely center thing. Okay, so I mean, nothing new, nothing fancy here. You probably haven't even learned a thing yet, but that's okay. I want to get right into sort of the data aspect of this app. So the deck of cards API. This is a pretty cool API. It's honestly like, I think it's more meant for kind of like learning how to work with APIs anyways. It's, there's a lot like, honestly with this, if we were building this app, there's actually no real need to use this. We could kind of implement all this logic client side, basically kind of storing the state of a given deck and actions for shuffling and that kind of thing. But I think it'd be fun to use this to be able to actually pull things accordingly. This API is essentially free to use, which is sweet. It's also open source. So if we wanted to, we could self-host this. It's a Django app built in Python. But we will just work with it this way. So the way it kind of works is you can ask for a deck. And when you ask for a deck, you shuffle it. So it's giving you a deck back already shuffled, which is sweet. And you can actually ask for multiple decks. So something like Blackjack, might have 6 or 7 or 6 decks in it. So you actually get 6 all shuffled together. We're only going to work with one. We're going to keep things basic. But we will build this in a way so that we could make it easy. And essentially, if you were to call this, and I can do it here to actually see, I get back a deck ID. And that's kind of the reference that I just need to remember so that when I'm, drawing from a deck, I pass this up and it knows, hey, this is cool. I'm getting back that particular deck. And it tells you whether it's been shuffled, and it tells you if how many are remaining in it. And obviously right now there's 52. That's standard in a deck of cards if you don't have jokers. Okay, so that's exactly what we got back there that I was showing. Then you can do things. So once you know the deck ID, which we would have gotten from here, we can actually draw cards, and we can draw 1, 2, up to 52, I guess. I'm not sure what happened if you try to draw 53. I assume some kind of error, but we'll see. And when you draw back, you get a similar response. You still get the deck ID just so you can remember it. And it tells you how many are remaining. But most importantly, you have an array of cards. And each card essentially has an image, which is super helpful because we don't have to worry about putting assets into our game. Of course, if we were trying to be, optimize things, we'd probably want to get our own images or download all these and keep them in our app. But again, we're just learning cool things here. So you get the image, you also get the value. So that can be something like a number. Now they are always strings. Just something to keep in mind with this API. So, 1, 2, 3. I'd imagine it's 1. It could be ace. I'm not sure. We'll find out. 8, 9, 10. And then I think it's Jack, Queen, King, all spelt out. And then you get a suit. And then there's like a code, which is just kind of like, I guess, the shorthand. Okay, 8 of clubs. I imagine 8D would be 8 of diamonds. You get the idea. You can also reshuffle. You can ask for a whole new deck. You can also ask for just a partial deck. So say you're playing euchre. You might be like, oh, I only want these particular cards, 9 and up. It gets you a new deck and ignores those other ones. There's stuff for piles. If you had like a discard pile, that kind of thing, you can shuffle piles. All this kind of stuff. Now, we are just going to be basically, at least for the purpose of this tutorial, working with, getting a new deck and drawing cards. And the API, this backend will essentially kind of manage our state remotely, which is an interesting idea. Again, probably not the most practical thing. It and we could always refactor this in the future to be like, I want this to be all client side, and that would be totally fine. But this is kind of cool, and it's also kind of cool if we ever wanted to make this a multiplayer game, because it's a lot harder for someone to cheat when the state is being stored in like a singular place as opposed to between two devices. So yeah, we're mostly just gonna be using these two, and then all the models that come with it. So without further ado, I want to build some models that represent a few things of our app. So let's see. Let's start with probably the most obvious one, a card. So I'm going to go here and I'm going to call it card model.dart. And we're going to make a class, and we're going to call it card model, not just card. The reason we don't want to use the word card is because card is something that's built into Flutter. So we'd run into like annoying issues on importing things and having to hide and show certain things. So it just gets complicated. Also, in general, I do like when I'm representing a model just to put the word model in it, because then like you're talking about a model. I've done this on a few projects, and I've been liking it. So we're gonna have a card model, and based on what we see here, we want to create some values. So and let's just I'll just try and make this a little more readable. We'll get rid of our sidebar right now. So we're gonna have a string that is the image. So that's like the image URL. I'm just calling it image because that's what they call it here. It's just gonna keep things simpler. We also want to have a suit, and I'm just going to make that a string for now, and we will make that better in a minute. And we also want a string that represents the value. So those are kind of the main things that we want. Now we are getting warnings because it's saying, hey, this is final, but it hasn't been initialized, and that is to be expected because we actually want to create our constructor. So our constructor, we go here, and we're going to essentially do, this dot image, this dot suit, this dot value. Now we're still seeing warnings here, and that's because we haven't marked these as required. And because they aren't, it means these might not be initialized. So we will put the word required in front of all of these. And then we have this lovely thing. Now, I am going to also make something here. Because suit, I'd rather store it as something a little more easy to work with than some uppercase letters. So let's actually make an enum for this. So we can do an enum, and we can call it suit, and let's have hearts, clubs, diamonds, spades, and I'm going to future-proof this and also just have other for now. The reason is, if we ever want to have jokers, that could constitute other. Also, there are some, card games that actually have more suits like anchors and stars. So let's just future-proof it and keep it like this. Now I'm getting this warning about preferring lower case camel constants, but I don't understand the thought process in this because I think like pretty much all Dart packages use this sort of convention. Let's just see what the quick fix does. Maybe I am misunderstanding it. No. So I'm going to actually just ignore this because I like the way this looks. I wouldn't really want it to be like this. I feel like maybe I'm wrong, but a lot of the time they are, uppercase like this. So we'll do that. We can always refactor later. Okay, so that's our card model. Now we're going to want some other models. Let's have a model that represents a deck. So I am going to go here and make a new file called deck model.dart and class deck model. And we definitely want to have something that represents the deck ID. And we want to, and I'm just following essentially this right here. We also want to have maybe a Boolean that represents whether it's shuffled. And let's have an int of remaining. Now, a couple things here. I've kind of just by habit wrote these to be final, but really when we're working with our deck, we want to be able to kind of toggle whether something's Boolean, and we want to update whether or not, or how many are remaining. So I won't actually make those final. Those be variables, but they will be required variables when you initialize this. So we can do deck model, and we'll do required this dot deck ID. So we need that whenever we create a new deck. We also want to have whether or not it's shuffled, and required this dot remaining. And it looks like VS Code kind of erased some of my stuff, which is annoying, but we'll deal with it. Now we have a deck model. And then we want one more model to kind of represent what happens when a draw happens. So let's make that model. Class draw model. And this will essentially have, anytime we do a draw, we're going to find out how much is remaining, as you can see here. And we also want a list of the actual cards that happen in that draw. That's pretty important. So we can say we want a list specifically of type card, and we'll call it cards. Then in our constructor, draw model, oopsie, required, this dot remaining. And we don't have to necessarily make cards required because we can say this dot cards and just set it to a default. So if for some reason we don't actually, well, if we create a draw and no cards get passed in, it'll just be an empty array. Now we do need to make the default a constant, and I put that in the wrong spot. Okay, so we have our draw model. Lastly, for models, we want something to represent a player. In this game, it's just going to be a two-player game. One will be a human, accessing the functionality through the UI. The other will be a bot that we will be building. It'll be a fairly basic bot, but my hope is that we're kind of drawing a foundation here that you could, in theory, build off of and make really smart bots. So let's make a player model. And it's going to be called player. Player model, as we've been doing. And let's give, when we create a player, it can have a name. It can have a Boolean of whether or not it's human or not. Obviously, if it's false, that means it's a bot. And we want to be able to track what's in a player's hand at any given time. So there'll be another list of card model called cards. Similarly to what we just did, we want to have required this dot name. Then we'll do the same thing, this dot cards, and it's going to be equal to a const of, that's like the default value, just an empty array. And we can also do this dot is human, and by default, we can just say false. So if we don't pass that in, we got a bot. Otherwise, we can choose either true or false. Okay, so we kind of have our very basic models here. So let's, and I'm just going to make this a little bit bigger for a moment. So this is nice because we'll be able to essentially call an API and instantiate these models and work with them, and we'll be able to add, our own properties and functions and helper methods to these as necessary. So let's get to the next part. We need to be able to call this API. So we are going to make a service, and I'm going to go into services. And I'm going to call it, I'm just going to call it deck service, because that's essentially, it's going to interface with, with some decks. This is not a widget or anything really Flutter wise. This is pure Dart code that's essentially going to go and create, call this API. So we're going to call it deck service. And what I want to kind of do is on the class, just add something called a base URL, just so I'm not retyping things out a whole bunch. Plus, if we ever did decide to, self-host this, we can just change in code in one spot. So I'm going to grab kind of everything up to the API there. So deckapi.com/API with the protocol and everything. Okay. So there's kind of some like boilerplate stuff I want to put in here because this is an API service. Now, in a bigger project, I usually kind of make like a core API service that you then create like the deck service to extend, which will have some of these helpers in it. And in fact, why don't we do that? Just to kind of show a good pattern. So I'm going to make something just called API service.dart and class API service. And instead of now that I'm actually going to move this to the API service. And we're going to put some sort of boilerplate stuff in here. I'm rather than typing it out word for word, I am going to just kind of copy some stuff in. And this is just boilerplate that I've developed and used in many projects. So the first thing I want to in my API service is a way to essentially to create like a URL. And because we're going to be using get parameters, this is something that is really helpful because we can just pass in parameters as a map, and it will automatically kind of do that. That essentially like question mark key equals value ampersand key 2 equals foo bar on top of the URL. So this is just kind of like a super helpful method where we just pass in a path, which doesn't include this. The path would be something like, /deck/new/shuffle. And then instead of passing in and writing of this tediousness, we can actually just pass in a map of key being deck count, value being 1. So this is super helpful. Now you're going to see we got some errors here. And the reason is our trim is something that's built into a package that we have not installed. So it's a very basic package, and in fact, let's kind of like rather than having to go back and forth and do things, I'm going to sort of install a few packages now. So let's just do Flutter pub add. First of all, we're going to need HTTP. Without that, we won't be able to make an HTTP request. So let's add that. And we're also going to add validators, and that's essentially the package I was talking about. And that will have the thing for rtrim and ltrim, which essentially just trims. There we go. rtrim, ltrim. Now everything likes me now. And what else are we going to need? We're going to be using provider, and that's going to be for our sort of like state management to remember, game state and everything. You could just as easily with this, with very little change, probably use something like Riverpod, or you could go really crazy and use block and various other things. But we're just using provider because it's kind of the most basic. Lastly, I want to use a cached network image. This just means this is a nice package if you're pulling images down from a server and potentially showing them in multiple places. It kind of caches it and doesn't recall that same thing. Okay, so we have our API service, cool, and now we have that. I'm also not, because we're going to be inheriting, I'm not going to make this a private function anymore, because essentially what we're working towards is deck service is actually going to extend API service, extends, plural, so that we can make use of all the lovely helper functions we're going to be having in here. So just to walk through this, essentially, and I'll clean it up a little bit, you have to pass a path in to URL. That's required. Otherwise, you can optionally pass in parameters as the second, which will just be a map. And this essentially just builds a query string. So the query string is just going to be empty. And if the params are not empty, we then add this question mark. This is very basic. And then we loop through all the params and we just kind of go k equals this, and we put an ampersand at the end. And that's just so that the first one will be this, and because like query strings are weird that they have, this is the first one, and then this is for every one after. And then at the very end, it also then goes, oh, I'm just gonna like make sure that there's no slash at the start, at the end, and no slash at the start, because we don't want to end up having, if I made a mistake in my implementation and put a slash somewhere, this will just clean it up and make sure that the path is always without slashes. And then we want to also remove that very last one if it exists. And then it returns a URI.parse, which is not quite a string, it's a URI, but essentially the same thing. Close enough, at least. Okay, so we have that lovely helper. And then I would also make helpers for, I'd make something for get, post, patch, delete, put, those kind of things. Now for this API, we only really care about get. So I'm going to, again, just paste this in, because it is kind of boilerplate and I'd rather just explain it. Actually, I realize we can make this private, because the only thing that ever calls URL is actually this internal thing, but this needs to be protected or public. Okay, so it's giving me a warning here, and that's because I don't have HTTP included, so we can just go import package H, and the autocomplete's kind of annoying. Bear with me. And then I like to do, as the docs pretty much always have said, and I always have done, as HTTP, so that we have it sort of namespace to this. And then you'll see that we're no longer getting errors here. We are on this, and that's because we need to auto import some stuff. So you'll see that imported also like that validators package. Or maybe that was, that imported convert, which isn't even a package, it's built into Dart. So what this does is I can call get, and I pass in a path and parameters, which is similar to here. And this essentially passes over that path and optional parameters to this function to build a URL. And then all we do is we get that URL using HTTP. We are awaiting because it is an asynchronous task. And then what I like to do is if the body is empty, which sometimes happens with GET requests, POST requests, I don't want something random like an empty string to be returned. So if it's empty, I just return an empty map. Otherwise, we JSON encode the body bytes of the response, which essentially makes a lovely map for us to work with. So there we go. There's our sort of core API. Now we might also want to have in the future, maybe there was something here that requires a post request. So we would make a post, and put and delete and all those kinds of things. But we'll be good with this for the purpose of this project. Okay, now back to sort of what we are really doing. I'm going to split some screens. We're going to pull deck service over here just so we can kind of see. So this extends deck service, meaning we have access to this get functionality here. We also have access to the base URL. Let's just create a few API calls that we know we're going to need. So I'm going to write these out and we'll kind of refactor as we go. But anytime making an API call, I know that the response is going to be a future of some sort. So I'll just do future void. And it's going to be a future because it is async. And we're going to make a new deck this is going to be like our function to be like, hey, I want a new deck. Essentially, like I'm starting a new game. And again, to future-proof this, I am going to optionally allow something called deck count. As we kind of saw here, you can essentially ask for multiple decks, like if you're playing blackjack. But we're going to default it to 1. So if we don't pass anything into this as this first parameter, it'll just be 1. And what does this function actually do? Well, this should be pretty simple to do because all we have to do is make a GET request, right? So we're going to go and I'm just going to make a final value called data. And it's going to be equal to, now I need to await this because I am calling an async function, but I want to essentially get, actually I'm going to, sorry, just because get's kind of like a word that is reserved, we're just going to call this HTTP get. HTTP get, and we need to essentially pass in a path. So not this whole URL, but the path. So everything basically from the from API onwards. So in that case, it would be /deck /new/shuffle, and we can pass in some parameters. And those parameters are essentially I didn't mean to click on that, or I didn't know it was clickable, but it's basically just deck _ count, and rather than typing 1 here, let's use this deck count that we created, and let's not forget that. And let's add, I like to put some sort of trailing commas. That just makes it a bit cleaner, and that's a little bit too much. Let's do that. That's clean. That's easy. Okay, great. So we sort of have this this lovely way to do things and call this. Let's just figure out maybe a way to test this before building it properly. So I'm kind of thinking out loud right now, but maybe in our main, let's go to our game screen. I'm going to make this a stateful widget so that we can kind of do some async tasks. And I can refactor this really easily in VS Code, Control-Shift-R, convert to stateful widget, and you see it kind of renames and makes everything. Which means now in here we do have a what is the what is it? A init state. That's what it is. So what we could do in this init state is actually call this service. So and this isn't the way we're actually going to do it at all when we actually make this. But I'm just going to make something called service, and it's going to be equal to deck service. This will be fine. And then we can go service.new deck. Now I'm actually going to, I'm just going to call this temp func because we will be deleting this. But I want this to actually be able to do this asynchronously, and you can't make an init state async, so you essentially have to call it from here. So we can do, I can just do final data equals await service.newDec, and let's make sure from this function for now we're just returning the data. And because of that, temporarily we're just going to say future dynamic. So we're essentially returning a future that resolves with just dynamic. This will be better. That means we should be able to print data here and see what happens. So because we sort of did a pretty big refactor there, we probably have to refresh our app with this green little button here. And we do get some issues here. And I was kind of expecting this. So now this is an issue that happens on Mac when you're building a Mac app, and doesn't generally happen with iOS, nor does it happen with web. And essentially there's a operation not permitted address. I can't access this on port 443. In fact, I can't access anything outside of this app. And that's just because the default of a Mac app is don't allow network connectivity. Don't worry, easy to fix. If we go into Mac OS, and then I believe in runner, and then there's a release entitlements and debug profile entitlements. And we need to just add a key here. And the key is, you can Google this. I've Googled it many times, like, what do I need to do? So it's com.apple.security.network.client. And like I have this whole AI bot helping me from GitHub, and it kind of helped me finish that, which was sweet. So we're just gonna allow that to be true, and I'm gonna copy this. So this is for the debug profile, but while we're at it, let's do it for release, because if we ever release this app, meaning like build a release version of it, this is the entitlement file that actually gets used. Now, because we're making a change kind of in like the really core part of the app in macOS, not in, this is when the Flutter, this wasn't like a Flutter thing. We actually have to, I believe, fully like rebuild this. So I'm gonna click stop. I'm gonna go back to my main.dart and click run. And we'll let that go. I do generally get warnings in Mac apps, but I mostly just use the Mac, we'll call it a simulator, even though it's not, for this sort of purpose of dev. These are just warnings, they're not errors. I'm sure we could look into them and make them even better, but likely this would be something we release as like a website anyways. Okay, so let's just see what happens. So look, we got, so essentially what happened in our game screen, a init state happened because this thing was initialized, and we called our, service.newDec, which is this, and we got some data back. So we got success, we got a deck ID, and we got this. So we know stuff is working. So I'm happy to kind of continue on. I'm just going to, I'll keep the temp function, but I'm going to just comment out the thing that calls it, just so we're not making API calls for no reason. So I was just kind of proving, yeah, this is working. Now, this isn't ideal though, because then if we wanted to work with our app, we kind of have this dynamic data. It's not really like something that we can really get any IntelliSense from, any type safeness. We essentially want to actually convert this to that model that we made. So we have like a deck model. We want to make, we want to return ultimately a deck model from here. Now you see this is an error because this is just map string dynamic data, whereas we want to return that. So how do we do that? So this is a common pattern. It's a factory pattern on your models. So we're actually going to create a factory, and we just write the word factory, deck model, and give it a name. And I like to use from JSON, as many people do. And we're essentially going to be passing in some data, and the data will be of type, as we saw here, map string dynamic, meaning the keys will be strings, but the data could be, the actual values could be strings, integers, there could even be another map. And that's how JSON is. And we'll call this JSON. Now factory is cool because we actually return a new version of a deck model when we call this factory. And it already kind of was like, oh, I have some ideas here based on what we have. So deck ID, now, if we're getting JSON back, how do we get that? Well, we can just type JSON deck ID shuffled, and this will be the same same thing, JSON shuffled, and remaining, JSON remaining. And we'll just kind of clean this up a bit. There we go. So now we actually have a factory, which will be really nice to work with. And so right here, instead of just returning data, we're going to return this deck model. Deck model dot from JSON, that function we just made, and pass in the JSON, which in this case is that data. So now, and I'm glad I didn't delete this because I do want to kind of show the difference here. So let's do this. Now we do have to do a green refresh because the init state has already happened in this hot reload, and the hot reload won't re-init state. So we'll just do the green refresh. And we'll actually see here the thing we're printing is no longer just JSON, not just a map. It is data, and because Dart's really awesome. This actually, VS Code knows what this type is. You can hover and you see, oh, it's supposed to be a deck model. So we could actually, call this deck, and meaning we could print something like deck dot remaining. And if we refreshed again, we should see 52 being printed. There it is, 52 after everything happened. So there we go. I will comment this out again. We may come back and do this though. Okay, so that's like our getting a new deck. Obviously an important thing to do. What other functionality do we need? I think one more thing, we need the ability to draw cards from that deck. So let's do this, and it's going to be a feature, and I will again just do void for now, and we'll call it draw cards. And we want to be able to, whenever we draw cards, pass in the deck we're referring to. So it's going to be of type deck model deck. And then let's have a int of count, and we'll default it to 1. So I can optionally pass, a parameter of count and be like, yes, I want, that, or it will just default to 1. In theory, you could pass draw 0. I'm sure the API would succeed, but nothing would come back. Okay, so in this case, we're going to make something data, and it's going to be equal to, this is very similar to what we're doing up here, HTTP get. And the path is going to be, and this, let's just see what it is, draw a card. So it's /deck, and then the deck ID, and then the word draw. So different than this. This was deck /new/shuffle. This is deck / parameter of your deck ID /draw. So let's do that. Deck / and we're going to, if we use a muddy sign here, we can kind of implant a little variable, and we're going to do deck.deck ID, and then the word draw. So that's our URL. As for parameters, we probably want to have some parameters. And in this case, we want to pass up count because it lets you do a count. And the count is going to be equal to whatever count we had. And let's just see how that looks. That looks nice. Now, similarly, we don't want to just return this. So we need another lovely function in our deck model, or sorry, in our draw model. So draw model, we're going to do the same sort of thing. So factory draw model dot from JSON and map string dynamic JSON. And we want to return from the factory a new implementation of a draw model, and it is going to have remaining of JSON remaining, and then what's the other thing, right? Then and I'm going to do, just to make this like a little bit cleaner, the other thing we have to pass in is the cards, right? And when we do this call, we get back an array of cards. So we essentially need to figure out what those cards are and actually use a factory on card to create an array. So I'm going to, for now, just do cards equal to this because we have to build something else first. But there's our factory for that. And we will go here, and we want to actually return draw model dot from JSON and pass in data. And you're seeing we're having an error, and that's because it's going to be like, hey, this isn't what you're supposed to return. It's a void. There shouldn't be any return, but we want to change that. So there we go. So this will work right now, except we won't have anything about the cards. We'll only have the fact that there's this many remaining. So let's just get the card one out of the way so that we can update this. So in our card model, Let's make a factory for this. Right, so factory card model dot from JSON. You've seen this before. Map string dynamic JSON, and we want to return a card model. Card model. Okay, now the image. That's pretty simple. We should just be able to go JSON image because it's just a string. Now suit's going to be a little more complicated because we don't actually want to store in our card model. We can't store. Oh, I realized we did this, but we never actually made that. The type of suit is not just a string; it's this enum. So we're going to need a way to handle that, which we will. Whereas value is actually pretty easy. It's just going to be JSON value. So how can we convert this to that? There's a few ways to do it. I like to sort of have a static function on my card model that deals with sort of the back and forth of these things. So what we can do is let's make a static function that is going to return a suit, and we're going to call it string to suit. Pretty obvious, and it is going to require you to pass in a string that we'll just call suit. And what we're going to do is a switch statement. So this allows us to take whatever that suit is and handle things based on what it is. So we might have a case of hearts. As you can see over here, it comes back in uppercase. Now to make this really like safe, in case the API like comes back in lowercase, we don't know. Let's just always convert when we do this to uppercase and then also trim it. That way, if there is for some reason extra white space, it's gone. And this will just make it more, more likely not to fail. And in this case, we would return suit.hearts. Now we need to do this for all of our other ones, which I am not going to waste your time doing, but we have hearts, clubs, diamonds, spades, and then I set a default just in case like something weird comes back that isn't handled. That's a good time to use our other suit. So we have that. So that's helpful. That's nice. In which case, now that we have this, we can actually go suit.string from JSON. Am I doing that right? Sorry. Oh, string to suit. And actually, I can just call it this way. And I want to pass in JSON suit. So this will essentially will pass in that string of like all uppercase hearts, and it will return out and create a heart. And we're not seeing any issues here, so we should be good. Similarly, it might be helpful in the future to have a backwards version of this. So I am just going to put that in now, and you'll see, I'm not going to type this out for you guys. It's basically the same thing, but the opposite. It's just it returns a string instead of a suit, and you pass in a suit instead of a string, and it does the cases on, the actual enum and returns, a string version of it. That will be helpful, I'm sure, at some point. Another helper that I am just going to put in now that need not to explain too much is this guy here, suit to Unicode. So this will actually, when I pass in a suit, it'll return this is the emoji value of a heart, of a club, of a diamond, of a spade. And similarly, I would like to have one that gets the color based on the suit. And in this case, we want colors.red and colors.black. So if it's hearts and diamonds, it would be red. And this is something cool about case breaks. You can actually have multiple cases that kind of cascade into this. So you could just as easily do this a bunch of times and do the blacks, but I just put my reds together with red, otherwise black. And technically, we could actually just change this to say default, because we want anything else to be black if it's not those two. So let's do that. So yeah, sorry for not typing all those out, but I think it's better just to, just to get through all this. Okay, so we have our lovely card model updated. So now what that means is instead of passing this, we can actually do something really, really awesome here. So what I'm going to do is make a variable called cards. Cards. And what we want to do here is take whatever is in that JSON of cards, and we want to map it, meaning, essentially loop through it and apply something different. And what we'll do is we'll call it card. And for everyone, we want to actually create a card model dot card model, I don't think is imported. That's why card model.from JSON. Now I don't want to pass JSON in because that would be like this whole object. I only want this part of it. So we're just going to pass card, and we want to make sure we convert this to a list after, to list. So that will get us our cards, meaning we can put cards here. Now, one other thing, we will get a bit of a complaint from the compiler because it doesn't really know what these things are. So what we can do right after our map is just say it's going to be a map that is, essentially returning card models each time. And that'll just keep everything clean and tell us that it's happy with us. Now I could do it this way, and this is perfectly fine. This variable is not really required. I could just just as easily do it this way, but this is a little bit messier, obviously. So I kind of like having when you're doing this more complex stuff, make it a variable and throw it here. It's not going to create any performance issues. Okay, so now when we do a draw, we get cards and everything is great. And I think that's kind of our deck service. So let's just let's kind of like sandbox this stuff a bit. We'll go back to our, I think it was on the game board. No, game screen. So we have this temp function. Let's kind of do some stuff where we get a new deck, and then let's make something called draw, and it's going to be equal to await service.draw cards. And remember how this works. We'll go back to our service, deck service. So draw cards, we need to pass a deck in, which look, it's automatically, just because we named things nicely, it kind of figured it out for us. And then count, we can say count of 2 or count of, let's do a count of 7. So first of all, let's just print, deck dot remaining at this point. Then we'll sort of print just like a little thing. And then let's print draw dot, let's print draw.cards.length. And this is poor man's debugging here. And then let's print draw.remaining. Okay, so let's refresh. So we should see when this initializes state that, nothing happened. Oh, there we go. So we do have an error here. Probably just a small silly thing. Let's see what might have gone wrong. So if we kind of go through the stack trace, we see cards. I think that's right. Did I to list in the wrong spot? No. Okay, so we got type list. Let's look at our, we can open up our network inspector. And let's just, it won't show us history, but we can refresh. So let's see what actually happens. Maybe we made a mistake with our API. Who knows? Could be anything. So first of all, we get the, so this is the one that got our, just our deck, which didn't seem to return anything. Okay. Although this debugger is very, I think this worked because otherwise how would have we known what deck ID to use? But okay, so we're getting cards back. So there's probably just some silly thing. Hey, there's actually more in this response than their docs say. You can actually get an SVG or a PNG. That's kind of cool. All right. So it's saying unhandled exception, list card model is not type of list card. Oh, yeah, that would be why. Where are we doing that? Yep, here we go. So this was kind of what I think I referenced this earlier, how using the word card is a problem, because this card actually is, if we look at it, is our stateless widget card that's built into Flutter in the package material. Okay, this should be card model. And let's refresh and see if our thing does what we want. Where's my game screen? Okay, there we go. So the first print was showing there's 52 cards in the deck because it was a new deck. There was 52 still remaining. Then we did a draw, and we how many cards are in that draw? Well, it says 7 because we drew 7. Then how many are in that draw, in the remaining of that draw? 45. So 52 minus 7, 45. Math seems to check out. All of our stuff seems to be working. We could actually also decide to print, loop through the cards and print them, but I mean, showing that in this sort of like terminal window is going to be kind of annoying. We should have UI to represent all this thing, which will be what we'll be doing next, is starting to get a bit of the UI together, showing a deck of cards, the the fun stuff. But we have some of our, our important stuff out of the way. So look forward to continuing this with you on the next video. Stay tuned, and hope you are enjoying it. All right, continuing where we left off, although we will start with a quick review of everything because we've been moving at, I'd say, a pretty good pace. So we have this very simple main.dart file, which essentially its only child, or its home screen rather, is the game screen. You can see in the game screen, currently it's a stateful widget. We have sort of this temp function here just to experiment with what we've been building. Essentially right now this screen doesn't do anything other than has a button that says new game and then has the game board, which really is just game board. So no real UI work yet. We've been working on sort of like the models and our services. So to look at some of the files we've made a model for each of the things we care about: cards, decks, a draw, like pulling one or many cards, as well as the player themselves. Looking at a card model, for instance, we have things like an image, a suit, and a value, so on and so forth. We also built a service, and this service right here, the deck service, is what works with our API. Again, we are working with this deck of cards API, which is really, really interesting to work with because, yeah, I think what I mentioned in the last one is, this API, I think was even originally made for kind of just learning purposes. We could very easily rebuild a lot of this logic client side, and it would not be a problem. But just kind of trying to show the common things that happen in any standard Flutter app that has to deal with an API. So that's why we're using it. So we have ways to essentially get a new deck, and we have ways to draw cards from that deck. So when we get a new deck, we call this, the API, and because we're inheriting our own API service, we have things like a base URL and some helpers to do an HTTP GET, so on and so forth. So we call it at this path based on that base URL, pass in, however many decks we actually want to work with, and we generate our deck model from JSON, which is a factory that takes that JSON and actually creates and returns a new deck model that we can work with. All right, one little thing I want to do, there's sort of in Dart, you're not really supposed to use, underscores for your variables. However, to me, it makes a lot of sense to use it so that it maps one-to-one with your API, so there's not some weird confusion. So I like to, I don't have a problem with this in my models, and I like to just kind of, for the file, have this guy here so that I don't get those lovely warnings. Yeah, so something that's cool, just as a side note, in VS Code, is it does give you these sort of warnings, errors, that kind of thing, and we could actually go through and fix these. For instance, it's telling me we don't need this file anymore. Cool. It's also saying avoid print calls, and I'm cool with it because we were just doing this to experiment. And then we have some constant constructors, which we can of course fix, and everything will be good there. So that's nice. It's nice to go in here and try and clean stuff up, keep things, refactored and nice. But I will ignore these ones because they will be gone when we actually make this. Okay, so what's next? I think we should do maybe some UI stuff just to kind of get things looking a bit pretty. So I'm just going to close everything. In VS Code, you can do Command K and then hit W after, and it will just close all your tabs, which is nice. And let's make maybe some components. Let's start with what should we start with? Let's start with maybe a playing card. Sure, let's create a playing card. So we're going to make that playing card.dart. So this is, essentially the, a card, a jack of spades or whatever it is. So we're going to create a stateless widget for this, and we will call it playing card. Now, I don't like to keep this open when I'm actually typing because it just starts throwing all these errors. Because of course there's errors. I just started typing. So I am going to go back to just my terminal window here so it doesn't annoy me. Okay, so in a playing card, we want to have a few things that we pass in. One of them is an actual card model, which we'll just call card. We also, let's pass in a size, just so we can kind of, if we ever wanted to make this, for iOS, make the cards smaller so they fit better, we can have that. Let's also have a Boolean called visible or not, because sometimes a card might be, face up or face down. We'll just use the word visible for that. And then that's good for now. And then we need to make sure that we are including these. So we definitely want to make sure that we are passing in a card. So we'll make that required, because without the actual card model representing the card, there's not much we can do. We'll also pass in, we won't require size because we'll set a default of 1. Size to me is going to be like 1 just means it's like 100% of whatever we set our default to. But you could, this is a double, so you could pass in 0.5 if you wanted a small card, or 2 if you wanted it twice as large, so on and so forth. Also, we need to do this dot visible, and by default, let's just make it false. So then we have a new playing card object. So let's go to our game board, which currently just has this text. So I'm no longer going to make it a constant. I am going to instead pass in the playing card that we just made. Now it is requiring a card. So for testing purposes, let's just make our own card by going card model. And we have to pass in an image. And again, I'm just going to kind of, this is just temporary. So let's just pass in, this stuff here. The suit, it's a king of hearts. So we should be able to just go suit.hearts. And the value is, what did they say the value is? King, all in caps. So then at least we have like, a card we can work with. So that means I can pass in card as card. And let's set, we'll keep size as 1, that's fine, and visible equals true, because we want to see the front of it. Okay, inside here, we do have a container. Now, I want to make sure that our container has a certain width and height. So what I'm going to do is actually in my main lib, just make a file called constants.dart. And this is where we'll store kind of like certain constants. And I'm going to have a constant called card width. And it by default will be, and it's based I base this number off of this image. If we actually look at this, and I think if we inspect elements, we get, it'll tell us like kind of what it is, 226 by 314. So 226, and then const card height. And the reason I'm making these constants is because, they're not gonna, the defaults aren't gonna change, and it allows us to essentially reference them in different places that are gonna need to know it. For instance, showing the back of a card, front of a card. Now this is if we were to keep this exact size, this is pretty large, especially if it was like an iOS app. So I'm actually just right off the bat, just gonna do divide by 2. And because these are constants, they get compiled at runtime. There's no performance issue. Like you could do any mathematical equation here. I could just do this in my head or on a calculator, but let's just do it that way. So we have card width and card height. So what we want to do then in our playing card is make the width whatever the card height is, or the card width is, but let's multiply it by this size variable. That way we can change it. And same with height, card height. And of course, when you multiply by 1, which is the default, it's just going to be whatever that's set to. Let's give it a decoration, box decoration. And it's going to have a border radius, because we want to kind of give our cards a little bit of a corner. And we can do border radius dot circular and maybe 4.0. That sounds good. Then, so that's kind of like our container. And let's, in order to see this, let's just give it a color too. Color, oops. Colors dot red. Sure. So now if we go back here, we didn't actually save this file yet. Card height is not defined. I didn't actually. Something that's kind of annoying. It's not annoying, but it makes sense. VS Code, even if you haven't saved a file, is already kind of like looking at your file changes. So it was, saying, yeah, you have access to this, but this file was never saved. So Flutter's like, I have no idea what that means. There we go. We have like a playing card just with that sort of red. You can see that little stuff there. Everything is good. Okay, so that handles, just the kind of the container for it. But we also want to actually, within that container, put that child. So first of all, we need to know whether it's visible or not. Because if it's visible, we obviously want to show, the face of the card. So if it's visible, and we can use a ternary expression here. So when it's visible, we're going to use that cache network image. That's that library we installed. We can actually just pass in card.image, and let's give it a width of card width times height, times size, and a height of card height times size. So this should always be the same, the same size. And then when it's not, I'm just going to do a container for now. We'll fix that in a bit. So now if we go back here, we should see, boom, there's our, our King of Hearts. Now we have this red here that in theory we don't actually need. So we'll just get rid of that. Okay, now I also want to have something that kind of represents, the back of a card. So we're actually going to make a new component for this, just so we can reuse it. So we'll call it card back dot dart stateless card back. And as usual, we need to import material. Boom, materials imported. Our card back is just going to take, at first, just a double of size. And this is so that we can pass that size parameter on. And similarly, this dot size, we're not going to make it required. We're just going to make the default a 1. And we're going to have a container, and it's going to essentially, and I'm just going to look at both these together because we kind of want the same, this same sort of thing. It's going to have a width and a height. Width with height. And let's just give it a color, colors.blue or something. And now we can use this card back whenever, and this can be a constant because, oh no, it can't be because we actually want to pass in that size, just so that if, there we go, size. And I don't think we need this trailing comma, just keep it a little more clean. So now here it's gonna look the same, but if we were in our game board where we pass visible, let's make visible false. And we see we have the back of there now. Now there's no border radius thing happening there. And I think that's just because we need to do, I think it's overflow or clip behavior. Overflow dot, oh no, it's now something changed. Clip dot anti-alias. And then we should see, so basically this is the thing that we have that that lovely border radius happening, and anything within it, if it's, it'll get clipped out when you have that. Without that, you'll still see that, that the thing extruded outside of its parent. So we want to keep that clip behavior. Okay, so we got that. Now we could very easily, and we won't do this now, but we could, of course, in our card back, actually return like an image that looks like the back of a, the back of a playing card, bicycle card, whatever we want. But I'm totally, fine with this to represent the back of a card. I want to use maybe blue-gray though. There, yeah, it looks great. There's the back of our card. Awesome. So we have a playing card. Now let's go back to here and obviously make it true. And just to show like how this could change, if we made this the King of Spades, I'm just assuming that's going to be the convention. Spades, we should see that we get, that back. So there we go. We have a playing card. Okay, so that's a little bit of UI, which is cool, but it's not really dynamic yet. We're not pulling it from a server. So let's kind of start to get some of our game logic in place. So we're going to go into our providers. Now this is going to be kind of the meat and potatoes of our app. Game provider.dart. This is essentially what's going to kind of control the state of our game. Where like bot logic will happen. And this is the part I'm most excited about because my plan is to sort of build this in a way using abstraction. So we're essentially going to have a class that represents a game in general, like a basic card game. And this basic card game is literally a game where you can draw a card and you can discard a card, and that will be mostly it. And then the idea would be that we will actually have something that would inherit that, such as in this example, it'll be crazy eights, but you could also, in theory, make euchre, you could make whatever, and it will rely on kind of the core stuff we're building now, but override things as necessary. So without further ado, let's get into this. So we are going to be using a package called provider to sort of deal with our state. And it's going to make it really easy so that when things change in our game provider, in essentially our game state, the UI will just update accordingly. So we don't have to think about it. I remember doing, code long time ago in like very basic JavaScript. And one of the annoying things is just because you change something in memory doesn't mean the UI is going to reflect, and dealing with all that's annoying. Obviously, like things like Angular and React has made those lives a lot better. And in Flutter, there's many different ways to do it, but I do like provider. Riverpod's probably my go-to on real projects, but they have so many similar principles that I figured let's keep this as basic as possible. Okay, so our game provider. So this will eventually be what's called an abstract class, meaning you're not going to be able to actually work with it directly, but that will come at a future time. We're going to build this as if it's not abstract. Now, game provider, we're going to add a mix-in. So this is kind of like extending something, but it's more, mix-ins are a little bit different than how we like extended our API provider. It's a way to kind of get the functionality of the change notifier without actually like directly relying on it. So we're using change notifier, and that's just built into material, nothing special there. But it is what something like a provider will be, wanting to work with. Okay, so in our game provider, we want a constructor. So anytime the game provider gets created, which in the cycle of your application should just be one time if you build it properly, but we want to initiate something called our, a service. So we're actually going to have something that's going to be late, meaning late is kind of a cool thing in Null Safety. From what I understand about it, it's kind of like you're making a final variable, but it isn't initiated until after your constructor happens. So we essentially want to make our service equal to deck service. Now you'll notice I'm using an underscore, and that's because there's certain things in here that I don't want. I don't necessarily want anything that's inheriting it or like an outside class to directly work with. So this makes it sort of private. So we have our service, and that's all we have. We're also going to want a bunch of other stuff, like things to manage, like what's in the deck right now, who the players are, what's been discarded, and so on and so forth. So let's do that. So let's start with we're going to have a deck model, and it is going to be nullable because really until like when this boots up, we don't necessarily have a deck at first. So we need to call that API. So we're going to call this current deck. And you'll see I'm using underscore again, and then you're going to see this. This is a sort of like a philosophy that's used a lot, where you kind of have a public getter for these things. So we will also then put deck model, which can be null, get, and we'll call it current deck. And all it's going to do, and we can do this really easily, is just return current deck. So this means like we're kind of decorating the code that we're making to allow current deck to be accessed. But because it's a getter, you can't actually then like do anything with it. It's just, give it to me, and it's going to give you this sort of like private version of it. So this is kind of like, you think of it as like a proxy to get access to this publicly. But you can't really do anything, like you just get a reference of it. So we want something for that. We also want something to represent the players. So we're going to have a list of players, list of player models, because that's the model we made. And we'll call it players. And we are going to instantiate this right away as just an empty array, which is cool. Now, this warning is just saying, hey, this isn't being used because we haven't used it yet. So we can ignore that because we will be using it. And similarly, we're going to have a list of player models, and I'm just going to copy and paste it, called players. And it is also going to be a get. So, and what it's going to do is just return whatever players is set to. There we go. Boom. So we have players. What else do we have to track? So we have our deck. We have this. Many games have the idea of a discard pile. So let's also have a list of card model. And that's going to be equal to, or we're going to call it discards. And we'll instantiate it as empty because generally it's just it's empty at first. And then let's make a list of a card model. Again, a get of discards. See this pattern? And it's just going to return discards. It's a little bit of extra typing to do this, but it just makes your code a lot more safe because you're kind of decorating what you want other files to work with and whatnot. And then let's make something that's useful in a lot of games is what's at the top of the discard pile. Like for instance, in Crazy Eights, it's important to know that there's a king of hearts. So I have to play a king or I have to play a heart. So we can actually do something where we return a card model. And it might be null, like if there's nothing in the discard. So, and we're just going to call this discard top. And what it's going to do is it's going to take the discards, and if it's empty, so if there is no discards, let's just return null, which allows a question mark, meaning like this is nullable. Otherwise, we're just going to return whatever's in the last spot on the discard. Dot last is just a nice helper. It's essentially the same as kind of going, discards dot length -1 to get the last index. But why write that when you can just go dot last? So there we go. That's just something we might want it at some point. Just try to make this as easy as possible. Something else that would be helpful to have is, and this will definitely come in handy when when we're inheriting and creating, games on top of our, base game. I like to just have something called like a map string dynamic, and we're just gonna call it game state. So this is something where the programmer, us in this case, or whoever's building a game on top of our game provider could just store things randomly and update them. So there's no this is string dynamic. It could be like, hey, you could store like the value of Trump in here, which is something I don't necessarily want in my base game because not every game has the concept of Trump, but just something to sort of remember things. So we will keep that. Okay, and then we need something to represent kind of like a turn, because in a turn you have, a current player, and we want to know like we're on turn number 7. So we could just have a lot of, variables like turn index, current turn player, blah, 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 blah. But this is a good case just to have another model. So we are going to make a new model. Now, this won't be a model that ever we call an API for and actually, work with in that way. It's going to be more, we're going to work with it just in, in this provider. So class turn. So something that is happening on a turn. I mean, in general, you obviously have players that are cross between turns. So I am going to make a list of player model, and you'll notice this is final because when we instantiate this turn object, this turn object is going to be kind of used throughout different parts of our parts of the app. We are going to require this on create. So let's just actually make that now. Required this dot players. Cool. Then we're going to have these will not be final. The rest of these variables will not, because these will change. I don't want to every time a new turn happens actually instantiate a new object. I just want to update the idea of what's happening right now in this turn. So for instance, we're gonna have an index of this will start at 0, but so on and so forth. It's also nice to just keep track of the current player. Who's the current player right now? Draw count and action count. So and eventually there might be other things we want to keep track of, but this is be on that turn, how many cards were drawn, so that we can build rules like you're only allowed to draw 1 per turn, or how many actions were taken, playing a card or whatever. So let's put the rest of these in. We want to, when we create it, actually require the current player, this dot current player. The rest, let's just do this dot index. By default, it's 0 when you create it. This dot draw count equals 0, and this dot action count equals 0. So we got that. Now we're going to store the current player, but it might be nice to also store who's the opponent, who's the other player. But assuming this is a 2-player game, for the purpose of now, it will be. We can actually just create sort of a getter for this, which will return a player model, and it'll be called other player. And all this is going to do is return whatever players we have, and it's going to find the first one where, and we'll just, instead of calling this element, let's call it P. And we will say where P doesn't equal current player. So it's going to return, the first one it finds. So if there was like 3 players, we would probably want to update our logic because it would just kind of almost randomly find, the first one that doesn't. Uh, in that case, we'd probably call other players and return, just make this a where clause where it actually returns multiple. But this is perfect for now. So we can, on our turn, be like turn.otherPlayer. Cool, it's going to give me the other player. And that's just going to be helpful for as we build stuff out. Another thing we're going to want to do is end a turn. So we can build that logic into our turn model as well. So I'm going to make a function. It's not going to return anything. It's void. We'll call it next turn. And it is a function. So what it will do is it's going to go index plus equals 1. So whatever our index is, it starts at 0, but when we go next turn, we want to increment it by 1. We're now on the, the second turn, meaning index of 1. We can also just, whenever the turn ends, we can essentially swap the players. So in this case, and we're going to keep this basic, assuming a 2-player game, but this could be updated in the future. We're going to just be like, okay, if the mod of the index of 2 equals 0, which is just a way of kind of saying, is it an even number? Is the index even? Then we can go players 0, otherwise players 1. So this is essentially saying, if our index is even, we're changing the player to be this one. If not, we're changing it to be the other person. Again, if this was multiple, if we had more than 2 players in this game, we'd have to update this logic. We also want to set the draw count back to 0 because the turns end and the action count equals 0. And obviously, if we ever wanted to track other things, we'd want to revisit this function and make sure that that we're resetting things back how they should be. Okay, so there's our turn model. Pretty simple. And the reason we made it really is because we also in here, and I'm going to do it actually up here because turn is a pretty important thing. We're going to make a late object called turn, and we'll call it turn. We also need to import turn. And similarly, we're going to have a getter of turn, and it's just going to return turn. Return turn. Cool. Okay, so I think that's most of the, there'll be some other things we add, especially as we actually make the game a little more interesting, but this is a pretty good start. Okay, what are some things we want to do? We're going to, yeah, let's make, there's going to be quite a few functions we'll be making here, but let's at least make one so that we can start seeing this in UI, because I'm sure currently, I'm doing my best to explain, but seeing things visually is probably a lot easier. So I'm going to make a function, and I know that this function is, this is essentially going to create a new game, meaning I need to get a new deck. And luckily, we've done all the hard, heavy lifting for getting that from the server. So it will be a future because we are doing something asynchronous, but the actual function itself won't actually return anything. So we're going to call this new game. And I think when we create a new game, we should have to pass in a list of player models, right? And we'll call it players. So we're creating a new game. Now, when we create a new game, we need to get a deck. So we're going to go final deck equals, and we need to await, and we're going to use our service that we've already instantiated. Remember this service here to go new deck. Now you're seeing this is being underlined. That's weird. Why? Oh, because we need to actually, just putting future here isn't enough to say we're using async. We actually write async here. So then we get a deck. Then we're going to want to set that deck. So we could, I could basically just go, and in fact, I'll do it this way for now, and we might update this later, but we just want to set current deck equal to deck. Now, see, I am accessing a private property because I can. I'm within this class, and I want to in this case. Which is fine. But my UI that's going to be working with this service will never have access to this. It will be accessing, the non-underscore version, the protect the public one right there. So yeah, we get our deck, and then we set our deck essentially, and then we also want to set our players, and the players are going to be equal to whatever players we just passed in. So there we are. Then we're going to set, when we start a new game, we're going to make discards because we have that thing that's remembering, how many discards we have, which is this right here. We just want to make sure that it gets set back to nothing. Otherwise, there'll be some weird thing happening. And then we need to create our turn. So the turn is going to be equal to turn players, and we want to pass in players again. And the current player, we're just going to use players dot first. So whatever the first one is, which dot first is the exact same thing as doing 0. That just looks a little bit cleaner to me. All right, and then I'm going to make another function here just called setup board, because usually when a game starts, there's a little bit of setup that happens. We'll make it a feature, and we're going to call that here setup board. Now, currently, my setup board is going to do nothing, because in our super most basic, version of the game, there's just going to be like a draw pile. There's not going to be like, oh, you get 10 cards, you get 9 cards, discard, whatever. But this is where, when we're inheriting, we'll be able to do things. So setup board gets called. Very good. And then at the very end of this, we want to do something called, this is very important, notify listeners. So anytime, these things get changed in the code, the UI is not going to reflect it until you call notify listeners, because this essentially kind of is going to emit an event to be like, hey, some stuff changed, rebuild. So we need to make sure we have that. And we're going to have this in multiple places. Okay, so we have new game. Awesome. Now let's actually, start to implement this. So I'm going to go to my, first of all, my main.dart, because this is pretty important here. So normally your main function just goes, hey, I'm just going to run this app. But we want to run it and pass something a little bit more specific here. So I am going to essentially wrap this with what's called multi-provider. So I'm passing in something called multi-provider. Now this is part of the provider package, and this allows us to pass to have providers that can be listened to and whatnot. So the providers that I care about, I want to use a change notifier provider, not just a change notifier that will create an error that's annoying to debug. And in the constructor, in the build method for it, or the create method, we want to essentially pass in that game provider. And there we go. Then after that array, now I am using technically we don't need multi-provider here. It could just be whatever the normal one is, but chances are we will want more providers. So I like to just use multi-provider. But we do need a child here, and child is actually that the app itself. Now this kind of change, this is like such a high level, change. We will definitely need to do like at least a green refresh here, at the very least, for things to work. And we might get an error, but we didn't. That's great. Okay, so we have this, meaning we can access this provider anywhere throughout our app, and it is, what's cool about this. This is technically like a singleton. We're not going to have multiple instances of our game provider. So whether I'm accessing this in this screen or further down, it should be the same, the exact same instance of that game provider. Meaning you don't have 2 different games happening, and it gets confusing. Okay, so we got that. Then in our, let's do a couple things here. So I'm going to just close some stuff, and let's open up our game screen, which luckily already is a stateful widget. I'm going to get rid of our temp function. And we have this text button, right? So a couple things we can do. We want this new game button to obviously create a new game. So we are going to access, and I'm going to make this a late variable, and it's going to be final, of a game provider. And we're just going to call it game provider. So then we can access it in here easily. And if we had other methods, we could access it. But in our init state, we're going to go game provider equals provider dot of. And we need to say what kind of provider it is, and that's going to be game provider. We also have to import provider. You'll see, there we go, provider, except I didn't want it to do that. And we need to pass in the context, which we have access to anywhere in a stateful widget, not just in the build method. But we also want to then pass, in this case, listen false, because this instance of the game provider, or this like reference of the game provider, I don't want to be like constantly listening for changes, because I'm just actually accessing this, because on pressed, I want to essentially call that function of new game. So we can make this asynchronous, because we want to do some awaits in here. async. And we should be able to just go await game provider dot, and you should say new game. Now it's expecting something called players. Rather than building all the UI to be like, create your players, we are just going to, create that for now. And we can always refactor later. And it's going to be a list of player models, right? And they need to have a name. So one will be called Tyler, and is human true? And then let's make another player model, and we'll call him bot. And is human false? But if you remember, in our player model, the default is false. So we could also just omit this, but I will keep it just so it's really clear. And then we pass in players. Okay, so this won't really do much yet, but if we did click new game, we will see, a lovely error. So game provider has not been initialized. Okay, let's just do a hard refresh and see if we can figure out. Awesome. I mean, no errors showed. Let's see if, let's just see. We're opening up our network. I want to see if we click new game, do we actually make a network call? It looks like we do. So that's working. It is, essentially calling our game provider's new game, which the network call is happening because we're getting a new deck and all this stuff's being set up as expected. All right, so that's all we need to really do in our game screen for now. Obviously, if we had other UI functionality like, I don't know, restart game or whatever, we might, access things. So this is one way to access provider. And the only reason you want to really access provider in this way, at least in sort of the way I like to work, is when you're just trying to kind of like call a function. Like I'm not using this necessarily to get data. I'm just, using it to invoke a function that's here by using provider of game provider. Now for where it gets really fun is the other way to work with provider, or one of the other ways. So in our, where do we have here? We had a game board. And our game board, we really want to be essentially listening to the state of our provider and updating accordingly. So there'll be some magic that definitely happens in here. So what I'm going to do is kind of erase all this stuff because we don't need it anymore. And we are set instead. What we're going to actually do is return a stack. So a stack is like it's like a row and a column, except it's in kind of like Z space, so like coming at you, and it's going to have some children. And the reason I'm doing this in a stack is it's an easy way to sort of do alignment. So if we wanted something right in the middle, we can actually wrap our things in that. But let's just let's actually do that. Let's start with our align object in the stack. And we want to make its alignment alignment dot center, and its child will be whatever we're going to do now. And just to show what this is doing, let's grab this here. You'll see test 1, 2, 3. If we change this to top center, so you can see this is just kind of a nice, easy way if we wanted, because we're going to want to have some cards here, we're going to want some cards at the bottom, et cetera, et cetera. So there we go. We have that. Now within here, we are going to want this is where like our deck pile essentially is going to be. Let's figure that out real quick. In fact, actually, let's not even worry about that yet. Let's just keep test 1, 2, 3 because there's a lot we can do here. So you'll see I'm returning a stack, but really in the game board, I want to have something one level higher than that, which is going to be called, it's our consumer, essentially. It's the thing that's going to be consuming and listening for changes in our provider. So I'm going to wrap this in a consumer. Now there's no built-in helper for consumer, so I'll just use something like center and just change it to consumer. And we need to make sure we're importing this from provider. This is a provider package. Now, consumer actually doesn't use a child, but we need to pass a builder in. And the builder has 3 parameters. One is just the context, in case we want to work with the context downstream. Next is model, and next is child. Okay, so the one we really care about is model, because that's actually going to be like an instance of everything about our consumer. Now, something else we have to do here is actually tell it what kind of what are we actually consuming, and in this case, it's game provider. And you'll actually see now this just before, just to show, this is like, oh, it's just going to be an object. Like we don't know anything about it. It could be null, no idea what it is. But as soon as we actually tell it what it is, look, it's a game provider model, so we know what it is. And now that we have access to the model, we can do some sweet things. So I'm actually going to, so within, this is like the build function. So we actually want to, in here, return something like our stack and whatnot. So I'm actually going to grab this, paste it here, and there's some extra stuff we don't need, I think. I messed something up. Hang on, stack ends here. Let's just get rid of this stuff. Return, and then semicolon. Perfect. So we're getting some warnings here, and that's because it's like, hey, this could just be a constant, but we're going to make changes. So let's just refresh. Nothing should be different, but let's do something here. First of all, oh, right off the top, before we even do this stack, we should make sure that model dot current deck does not equal null, right? So just for let's get these things beside each other. So we have something called current deck, which is like a nullable field. And obviously, if there is no current deck, we probably don't want to try and show the deck because it'll just give us an error. So if it's not null, that's when we're going to return this stack. Otherwise, let's just return like a text that says, game, start game. Let's just make it say new game. Cool. So you'll see it saying new game. Also, our alignment got, oh, because this isn't within the stack. That's right. So let's actually wrap this in a center. New game. And we could actually take this, a step further if we wanted and actually make this like a text button and do, what is it? What is the text button? I forget right now. Child text. Oh, I did text button, but isn't it? Is it flat button now? No, it is text button. And needs an on pressed. And we'll just, okay, cool. So now we actually get this like new game, meaning like, we could actually not even worry about having this thing here. And what's cool is we don't have to do that whole like, provider of because we have access to it here. We can actually just say model.newGame and then pass in players. And in fact, let's do it that way. I like this a bit better. So we will copy this final player model, need to import our player model, model.newGame, cool. And in theory, although I haven't tested this, new game, model.newGame. Oh, something didn't save. There you go. So this was kind of interesting, very basic in terms of provider, but kind of when you first figure out how this flow works, it's pretty sweet because essentially what happened, we called new game and we didn't do like, this isn't even a stateful widget, right? This is a stateless widget. We didn't even go like, hey, set state, after that to update the UI. But because we're listening, it knew to rebuild because something changed. And the reason it knows something changed is because we have this notify listeners. If I was to actually get rid of this, and probably might require just a green refresh here, and do new game, technically this code ran, and everything, there is like a turn in memory, and discards are blank. Everything is good, but there was no, we didn't notify it, so it doesn't go. So that's pretty cool. We're able to do that. So I'm actually then, just to kind of clean stuff up, because I don't think we need a new game button in both places, I'm actually going to just fully get rid of this action that's in our game screen, meaning we don't really need this anymore. We don't need this anymore. And in fact, like this could just become a stateless widget now, which I don't think you could easily refactor. So we won't really worry about it because we might want state at some point. But yeah, now we've just put this in here. Actually, sorry. We do need to keep this button because if we didn't, this would, once we're starting a game, if we wanted to create a new one, we wouldn't be able to. Like for instance now, because there's a game happening, we wouldn't be able to make a new one. I'm going to go make a new one, cool. Now that didn't work, but I think it's just because we had a pretty big change. Let's just see, new game, test 1, 2, 3. Now if I click it again, in theory is working. As far as we know under the hood, it probably is, but there's no difference. It's just the code we have right now is like, okay, if there is no current, or if there is a current deck, show this. So let's, for instance, change this now to, instead of test, let's take model dot current deck dot remaining. Now we know, so this is complaining right now because it could be unconditionally accessed because receiver can be null. But we happen to know as the programmers that, hey, this will never be null because we're already doing that check here. So let's just go like this. And now you see test 52 because there's 52 cards in the deck. Perfect. Okay, so we're off to a bit of things here. Now we have no way to draw a card yet, so we can't make that number smaller, but we will get there very soon. Okay, so what I want to do is let's create a new component that represents kind of like our deck pile. So I'm going to go here, deck pile dot dart. And the deck pile will be fairly simple. We'll call it, sorry, this is a stateless widget, so we can do STL and just type this. It gives us the boilerplate deck pile. And we need to remember to import this stuff. So a deck pile itself, we will have an integer representing how many is remaining. We're going to have that just to kind of go with the idea of like because this is going to be represented by our card, we want to have that size property so that we can make things bigger. And lastly, we are going to have a Boolean representing whether or not you can draw from that pile. And let's just go and set required this dot remaining. So we always need to pass in remaining. This dot size, and it's just going to default to 1 like we're doing everywhere else. And this dot can draw, and by default, it'll be false. Okay, so within here, we essentially are going to use that card back property that we had, and we want to pass in that size. So we're just kind of forwarding the properties over. So now if we actually go to instead of doing our test thing here, let's just put our deck pile that we made. Oh, wait, what is, because it's requiring, we want to have remaining, and this is where we would use model dot current deck dot remaining, and again, exclamation mark there. So now we should see, instead of that, we actually have our back of our card. We have a deck pile, the card back. I do want, I am going to, because I realized playing card. Technically, I want on my, I want to grab this like exact same thing here that does the border radius, just so it has those corners. Now you're going to see this error. I was expecting this error. And this happens when, so you're allowed to put color on a container, but if you ever have decoration, you need to have the color within the decoration. And I think that's just so that like you can't put color in both places and then it gets confused. So now we just have that border radius. So that's all I was doing there. Just a nice UI update. Okay, so we're passing that. Now our deck pile is also going to, when we're doing a deck pile, I want to be able to show how many cards are in it. And we can essentially do that by passing something through here. So our card back currently doesn't support this, but we're going to have a final widget, and it's going to be allowed to be null, called child. Okay, and we're just going to go, we're not going to make this required because it's technically nullable, and we don't need it a default because it's nullable. And what I want to do here is we're going to give the container a child, and if it is, if child, what we can do is there's a couple ways to do this. So this is the most basic way. If child does not equal null, we want to pass child over, this guy here. Otherwise, we're just got like an empty container. Okay, now this is telling me this quick fix, which I am going to do. And this is just a much simpler way of doing that. This is essentially when you have the double question mark, it's like use this unless it's null, otherwise fall back to this. So that's a lot cleaner and obvious what's going on there. So the thing is now, the thing now is we could then pass a child over. So I could pass like some text, for instance, that has remaining in here. Now this is an error because it's an int. So we could either do .toString, which is kind of the ugly way of doing it, or we just literally put it in a string with a money sign and just go, oops, let's go remaining. So now we should see there that's 52. Cool. Now because it's a widget, it doesn't necessarily have to be a single widget, because a widget, it can be a widget with a widget inside it. So we can actually say, hey, we want this to be centered on the card. We also want, the style, text style, color, colors.white. So there we go. And then there's some things we can do. This is a constant that won't change. So there we go. It's telling us there's 52 in it right now. That's pretty cool. And we're getting somewhere now. So in our game board, which is where we've created this this deck pile, we essentially want to make sure that that we can draw a card from it. So what I'm going to do is actually wrap the deck pile in a gesture detector. There's no shorthand, at least in my version of VS Code for that, so I'll just use something that I know will work, like center, and just change it to gesture detector. You could also just do like wrap with widget, but it doesn't really matter. And gesture detector allows an on tap event, as well as many other events. And this is where we do our logic to actually draw cards, which we have. Okay, so in this case, we're just going to await. So this is going to be async, because we are calling an async function, and we're going to say model, so access to our game, to our game state, and we can do .draw cards, which maybe we haven't made that function yet. That's probably why. Let's go to our game provider, and let's see, what did we even make? Yeah, all we have is a new game. So we do need something to draw cards. That would be a good thing to do. So this will also be a future void of, and we'll call it draw cards. And when we're drawing a card, we need to know what player is doing that. So let's have the first field be a player model of player, and that's good. And then we can also optionally have an int of how many cards to draw, just so we don't have to call this function like multiple times. And I'm going to also just, I think that's all we need. Draw cards. So what we can do now is we can go final, and we can do a draw. And this is just using our service. Again, we need to make this async. Service dot, we should have something for this. See, we have the service for draw cards using the functionality here. And what we want to do is when we draw cards, we need to use whatever the current deck is. And because current deck's nullable, we have to put this exclamation mark. And we know in our logic, we'll never be able to call this. And in fact, we could extra protect this just by going, if current deck equals null, let's just return, so that nothing actually happens. So now we've like fully protected it. We'll never run into a null issue there. And then count, we're going to pass that count over, which by default will be 1. So we're going to do that. And something else that might be good to track, we have that turn object, right? So we can say, okay, a draw happened, and we can say turn.drawCount plus equals count. So that's just going to increment like, oh, this is how, that count, 1 card has been drawn this turn, or 2, or whatever. And then we want to take whatever our current deck is, and we want to just set its remaining equal to draw.remaining. So remember, our draw object itself, if we look at it, draw model, it has like this reference to remaining. It remembers how much is in it, and we will just set that to remaining, and all is good. Then, because we want the UI to reflect, we need to make sure after this function ends that we notify our listeners. Otherwise, none of this logic, this will be in memory, it'll be fine for the next time, but you'll skip out on like the rebuild until something else calls it. So now we have draw cards. And in this case, we have to pass a player in. So I'm going to actually use model.players0. Players, let's just do players at first. And this would be something we will, if there's multiple players, we need to make it a little more complicated. But in our game, the first player is like the human player. So we're good there. Okay. So I think this might just work. I'm going to refresh and do just this hard refresh. And one thing I love about building the Mac app, it's so fast that hitting this green button that cleans everything up is nice. So let's just click new game, and we see this. Now, in theory, if I click this, you'll see it's going down. And that's sweet. So I am drawing cards right now. We can't see it, but stuff is working. The next thing we're going to do is actually show what's in my hand and show, what's in the bot's hand, but most likely, we'll hide what's in their hand to make the game a little bit challenging. Yeah, hope you're enjoying this, and until next time. All right. As usual, I like to start these videos with just a quick review of what we've kind of done so far. Um, so we have a card game, new game, and it draws a deck of cards from our lovely deck of cards API. We can draw cards. The number in the middle is showing how many are remaining in this deck, and they are being drawn in memory, at least, to the player, myself, the human player. So the next thing we're going to want to do is actually set up, some cards down here of what cards I've drawn, because otherwise this is just this game would be very difficult. You wouldn't be able to do anything. So just to kind of review a bit of the things, in our lib folder, we have a few different components. These are like UI components, widgets, basically. So something that represents the card back that we were just seeing. The deck pile, which is actually just puts the card back on with a child of the number within it. We have the game board. This is where a lot of the magic happens when you're playing a game. And this is where the consumer is of our provider. So essentially, anytime our consumer does this notify listeners, this will rebuild, which will just keep everything in sync, UI and business logic. We also have a component for our playing card, which is just the playing card itself. Okay, what else do we got? We have some models. We have a model that represents the card itself, which is something we're using a lot. This comes from API, so we have a factory that converts the JSON to a card model, which just has a couple strings to represent the image and the value, as well as a suit, which is an enum we made representing the suit. We have some helpers to convert a string to a suit and also a suit back to a string. We have some helpers also for color and kind of getting the emoji symbol of these things. Okay, so yeah, there's models. We have our game provider. This is, probably where the most code will be written once we kind of get everything in place. This essentially just manages the state of the game, has functions for creating a new game, setting up the board, drawing the cards. What's cool is eventually we're going to be converting this to an abstract class, and we're actually going to build a specific game, Crazy Eights, for today. That inherits this. So ultimately, game provider will kind of be like a convention that is made that has a lot of the helpers and stuff, but will override certain things. Like for instance, setup board right now just doesn't do anything. It still gets called, but it doesn't do anything. But once we have an abstract class, once we're able to inherit this abstract class, we can create, in Crazy Eights, everyone gets dealt 8 cards, and the first card gets flipped into the discard pile. That's the kind of stuff you can do that will be different between, say, Go Fish. Aside from that, we have some screens, really just one screen. This is really just the scaffold of, of the entire game, and has the button to create a new game. We have a service as well. We have our deck service, which talks with our awesome deck API. And that inherits something that we may call API service, which is just a really basic thing that interfaces with HTTP library, the official package HTTP. That way we can just work with it in a nicer way and not have to, hard code in, for instance, deck of cards API. So that's kind of it. There's a few constants, just representing our card width and card height. We obviously have our main.dart, which all it's really doing is invoking the game screen, and it's also registering the provider. So that's kind of where we're at, and let's get to it. So the next thing we want to do is actually kind of create, something that's going to show the player's cards here. So I do want to make a new component for this, and I think we'll call it a, it's not the discard pile. This would be the, you could call it like a, a card hand or something. Naming stuff is hard. I'm just going to call it player hand.dart. Okay, so what we can do, you know what, let's actually call it a card list, I think. It's a little more descriptive. And we will make that a stateless widget to start. It may get upgraded at some point, but card list is cool. We'll import in material. And we need some things when you sort of create this. So first of all, let's, just so we can kind of keep that idea of size, just so we can make this more scalable in the future, we will allow passing a size in. We will also, a card list should be owned by a certain player, so we'll use our player model and we'll call it player. Let's also have a function that we can pass through. And it will be optional, so we can do this. And on play card, and this will make a little more sense after, I'm sure. And when we do a play card, we want to pass back a card model so that whatever is in, making use of this knows what card it is when the on play card is hit. That's essentially going to be, on pressing a card. We need to, in our constructor, have some things. We definitely need, we're going to require this dot player. We need that. This dot size is going to be 1 by default. It's kind of just a ratio of the card size. And we won't make this required because it is optional due to this question mark here. All right, now into the UI sorts of things. First of all, we want to make sure that this list kind of has a a height. Now this is going to be a horizontal scrolling list, so it's going to kind of go across the bottom here. So we do want to give it a height so that it doesn't get confused. So I'm actually going to replace this container with a sized box because we don't need to style it necessarily. And we're going to give it a height of whatever the card size is, which is that the card height, which is that constant we have, multiplied by whatever our size is. That will just keep things nice. And its width is going to be double dot infinity, which is just basically a fancy way of writing 100%. And it's going to have a child. And this we're going to have a list view builder. List view dot builder. I will erase these so we can do it one. First of all, as I mentioned, we want a scroll direction of axes dot horizontal instead of the default vertical. Item count. So we have the player being passed down. And if you remember the player model, one of its attributes is a list of cards, which by default is just an empty array, an empty list, but could have many cards in it. So that's what we're going to kind of use. So we can do player.cards.length. That's how many items there are. And then in our builder, we also need in our list view, we need an item builder, which takes context and also takes, very importantly, an index. And in here, we will make a function, and it's going to return something. Now, what I like to do is, rather than every time having to access it this way, it's nice to just make a variable called card, and it's going to be equal to player.cards index. So if you're not familiar with list builders, let me just, I'm just going to return a container so this can look nice. There we go. They are really efficient because they kind of like figure out all the math and heights of everything and all that kind of stuff. But it keeps a lot of the, if your list is really long and isn't going to be visible on the screen, it's efficient and keeps those things kind of like low memory footprint as possible. So basically what happens is this function will be called for however long your item count is. So if we have 10 cards, it's going to be called 10 times. An index obviously starts at 0 and would go up to 9 in that case, meaning we would be, in this case, returning a 9. If there was 10 cards, we'd be returning 10. 10 containers all in a list. But we obviously don't want to return a container. We're going to return a playing card, which is we've already made this. This is essentially where you pass in the card model that represents it, and it gets uses the network cache network image, which uses whatever card's image it is to display it, et cetera, et cetera. So we have a playing card. Now we need some things in here. We obviously need to pass the card, and we already have this here. Size, let's pass size just straight through. Visible, let's just do true for now, and we can make that dynamic after. And on play is something that we will eventually want to do, but we don't have that set up yet. So let's just see if this even, works. So we have, I'm just going to just restart. Oh, we also need to, so we've built this, we've built this, yay. It's not going to show up though, because we have to put it somewhere. So let's go to our game board. And essentially, just to remember what's happening, we kind of have this, this stack, right? And we put, so far it's kind of useless to even have a stack because we only have one thing, but we were planning on having other ones. So we're going to put another thing in this. Now with a stack, you can wrap any of your things in a line to say where in the stack it lives in like X and Y space. So in this case, let's do align, alignment dot bottom center, sure. And we'll give it a child. And its child is actually going to be the card list we just made. And we can pass in a player here, right? So player, and in this case, let's just do model.players 1. Or would it be 0? Let's use 0. 0 would be us. We're the first player if we go back and look at our game. So let's do that there. And new game. And if we draw, nothing's happening. I wonder why. All right, I realized we did miss a pretty important thing. So we are, in our game provider, we are drawing cards, but they're essentially just kind of going to the abyss. We're not doing anything with the draw. So what we need to do is actually when a draw happens, we know what the player is, and we need to add these, add whatever cards get drawn to that player. So what I'm going to do is in our player model, we're going to essentially add a function. And to allow us to sort of add cards easily. So I'm going to just call it add cards, and it's going to take a list of card models, and we'll call it new cards. And all we really need to do here is go cards equal whatever our current cards is, and then spread to add in our new cards. This is just a fancy way of combining two arrays, essentially, two lists, rather than kind of like doing, you could also kind of do cards dot, I think, add all and pass it in, but this is good. Cards equals whatever our cards are right now, and new cards. While we're at it, let's also make a remove card function where we can pass in a card. And what we can do is we can take our cards and remove where. And this is kind of like the case that we want to check to whenever we move it. So this is going to loop through all the cards, and we'll represent each in the loop as C. And we want to just check if C dot value is equal to card dot value. So if the C in the list value is equal to this card's value, and we also want to make sure C dot suit is equal to card dot suit. So it'll remove any time, like it could, in theory, if you were playing multiple decks, it could return, this could actually remove multiple. We could just do remove first where, or remove, there's something similar. But anyways, this will work for our needs. And while we're at it, while we're in this thing, let's just make we have sort of like something representing is human. It might be nice to have a getter just called is bot. We don't have to store it or anything. It's just a function that will return the opposite of is human. That way, if our logic is like we want to know if it's a bot, we can just ask without having to, go if not is human. Just fancy stuff. Okay, awesome. So we had this. We have our drawing of cards. The draw happens. We want to make sure right when the draw happens, we then take whatever player is passed into the draw card function and add those cards. So we can go draw.cards. Sometimes it might just be one card, but it will work as long as it's a list. And as we know in the draw model, this is a list that comes back, even if it's just one. So we have that, and we should be good. Okay. There we go. Okay, so I'm just going to refresh so it's kind of a clean game. But 52 cards in the deck, and I start to draw one. I start to draw one, and you'll see that I can, continue to draw these. So this is pretty sweet. This is coming for API. Now, because this is a horizontal list, you can scroll it. If you're on Mac, unless you get a plugin or something, you have to kind of use your, because it's horizontal, hold Shift and mouse scroll wheel. Obviously, if we deployed this to iOS, it would just be, or iPad or something, or Android, it would be, a touch sensitive thing. But this is good. So we're getting cards. Yay! Okay, so in our very, very basic preliminary game, the way it's going to work is at first, you're allowed to draw one card and only one card, and then you have to end your turn. So we need some functionality to allow ending of a turn. In order to do that, let's go back to our game board. And what we can do is, where we did this card list, which is right here, let's actually put this into a column. Now I'm going to make the columns height, main axis size dot min, just so it doesn't try and take up all the space it can, as columns like to do. So everything should still be the same. But within here, we're going to want to put a button. So what I'm going to do, just because we might eventually have multiple buttons, is we'll actually make a row here and give it some children. Cool. And let's just make the main axis alignment dot end, so that they kind of go to the end. And in here, we're going to put a button. We'll use an elevated button. And on press, we'll keep empty for now. And child will just be text of end turn. And this can be a constant. So now if we go here, we'll see the end turn. Now, might be nice to either put padding, or you could simply just have a size box height of like 8 or something. And this can be a constant too. This will just add a bit of padding between there. And in fact, now that I'm seeing this, let's actually put padding around the entire row. We'll wrap with padding, and then it kind of has it on both sides. So we have a lovely end turn button, which doesn't do anything yet. So first of all, in our game provider, I want to make some other helper functions. One of them is going to be it's going to return a Boolean, and it's going to be can end turn. And for now, and this is actually going to be a getter. So bool get end turn, and let's just return true for now. We'll just be like, yeah, you can always end your turn, and we'll update that logic later. Meaning, what we can do here is we could decide, we can use model.can end turn and have a function, and then otherwise do null. And I didn't save this file, so we got this error. And if we actually made this to return false, you'll see that this button's going to be disabled. So that's pretty cool. So we have that now. Then how do we actually end the turn? So we're going to make a function, and it makes sense to be kind of in the same spot as can end turn. So we're going to make a function. It's void, returns void rather, and we'll call it end turn. And remember, we have this turn object that we can do things, and it actually has, I think, something called next turn. So let's just look at what that looks like. So next turn increments the index of what turn we're on. It figures out who the current player is, and just this simple sort of function to find out if it's even or odd. And it resets the draw count and action count to 0. So we can do turn, next turn. And then because we're going to be, working with a bot, after we change the turn, we can actually in this point check if turn.currentPlayer.isBot. Remember, we made that function very recently, or that get. We can call a function, and we'll call it bot turn, which we haven't made yet. We also want to make sure at the end of this we notify our listeners, so that state updates. So let's make another function called bot turn, and I'll just keep it empty for now. Sweet. Okay, so now if we were to end turn, what's actually happening, if I'm clicking this, let me make sure I'm right. So, it's still giving it to me, right? Okay. So what happens here? Oh, right. Our card, okay, deck pile. Right, we're just drawing cards to the first player all the time here. Really what we want to do is, I think we have something called current player, or dot turn, or model dot turn dot current player. We really want to be drawing to, whenever that's clicked, to whoever the current player is. So let's just see if this even works. So I get my one card. If I was to end my turn and click here, still coming to me. I wonder why. Current player. Our logic might be wrong on the turn. Let's see. Current player. So we're doing end turn. We do the bot turn. Notify listers. Let's just, after we end turn, let's just print turn.current player. Okay, so I realized the reason none of this is working is because we are not calling that function. So let's do that. All we have to do here is model.end turn, and should work as I was planning. Let's see. So now, well, let's do a nice full restart. New game. Draw a card. I'll end turn, and then I'll draw a card. And that card is, we haven't made the UI for the bot yet, but in theory, it's coming there. And now coming here, and everything is good. Okay, so that's pretty good. We're off to something here. So we're going to call this bot turn, which we'll write that code in a bit. But let's improve our logic and get some UI for the bot as well. So checking if you can end turn is good to be able to make that button disabled. But we probably shouldn't even show this button if the current player is not not us. So let's wrap this. Let's actually just do an if statement here. If model.turn current player is equal to model.players 0. So basically, if these two things line up, we will show that button. So let's refresh and come back here. And so we do see the button. Now, if I click this, the button goes away because it's actually this person's turn. So we're good there. Secondly, let's copy our, let's do something similar, and I'll do it above here. We're going to make an align, and it's going to have an alignment of alignment.top center. And within here, we are going to just put in that card list. And so similar to what we're doing here, but instead we want the player to be model.players1. Okay, so now we can actually see what this person would have drawn. Great. Okay, so let's do a little bit of some sort of, I guess, AI kind of here. What I want to do just to make the bot a little more like it's thinking is we're actually going to, for the purpose of this, put some awaits in here to make it seem like they're thinking. So we'll start by just doing an await of a future.delayed, and we'll use a const duration of, let's just do like 500 milliseconds. So that'll essentially, like this function I called, we'll actually have to wait, in which case that's good. Let's also await the bot turn so that this stuff doesn't happen till, actually no, this can happen because we're gonna have something anyways. And then we're gonna do an await of draw cards. And this time we're gonna pass in turn dot current player, whoever the current player is. And in this case, it will be the bot when we're calling it. And then let's duplicate this. So there's kind of like draws the cards, or waits, draws the cards, waits. And then what we want to do is check if the bot's allowed to end its turn, which it should be at this point because we can always end the turn. We want to then call end turn. So now we should have a bit of a cycle here. So I'm going to make a new game. I'm going to click this and end my turn. Bot's going to draw something, and then now it's my turn again. But I end my turn. bot's going to draw something, I can draw. So we have, the simple thing. So let's put a little bit of logic in the can end turn, because our business logic should be something like if turn, we're going to return turn dot, we have something called a draw count. As long as it's greater than 0, we'll say we can end turn. So now if I'll end this turn, I'll do this. And then see, I can't end my turn now, but as soon as I draw this, I will be. So this is just checking to make sure, our rules of this game is you can draw one card and then you're done. Pretty boring game, but it will get more fun. Okay, so we have that. We have our little bit of AI happening. What else do we need? Well, let's see. So we can draw. We have no concept of playing a card yet. So let's do something like that. And by playing, we're going to, in this game, just to kind of make it closer to what we're going to eventually be building, which is Crazy Eights. By playing a card, we'll actually kind of like place it in sort of a discard pile. So let's create our discard pile. So we have this deck pile that's right in the center. I want to wrap this entire gesture detector within a row, and we will do a main axis size of main axis size dot min, just so it doesn't grow all the way, and we can have other children in here. So we're going to make a new component called the discard pile. Dart, and it will be a stateless widget. We'll call it discard pile, and we will make sure we import material. Inside the discard pile, we're going to keep track of what cards are in it. So there's going to be a list of card models. We'll just call it cards. And let's also pass in that size ratio. So we'll go required this dot cards and then this dot size, and we'll set it to 1 by default. Okay, so inside here, we are going to make the container have a width of, again, the card width times that ratio. And we will have a height of card height times the ratio of size. Then let's put some decoration on this, box decoration, and we're just going to give it a border around the whole thing. So we can use border.all and give it a color of, let's just use colors.black, maybe like 45 or something, and a width of 2. Then within this, we are going to have a child, and it is going to be a stack because we want to kind of have all these cards stacked on top of each other. So we're going to make a stack, and we're going to take its children. And rather than just like putting them in here, we're actually going to take all of our cards, and we're going to do a map on it. And each time it runs through this map, we'll refer to it as card, and we actually want to return that playing card, and the card will be that card. And let's also set visible to true, because if it's discarded, it should be visible. Then we have to remember at the very end to convert it to a list so that it conforms to stack children. Okay, so we have a discard pile, and basically we did this, we have this row already ready here, so let's just grab our discard pile. And we need to obviously pass in cards. So in here we have, we already kind of set up a thing for discards, so we should be able to just go model.discards, and that should start to show up. So now we kind of have this. I think a little bit of space might be nice, so let's just add a sized box, width maybe 8, and this could be a constant. And I'm just gonna get rid of this comma. I like my size boxes, just take up one line. So then we have our discard pile here. It's empty right now. Everything is good. So how can we put cards in this discard pile? Well, we're gonna make a function called play card. So let's put that, let's think of a good spot to put it. We have draw cards. I feel like right here is a perfectly good spot. So this will be a future, so it can be async, and we'll call it play card. And when we are playing a card, we are going to require that the player model, a player is passed in, like who's playing the card, as well as what card are they playing. Makes sense. And it will be async. Now, similarly, we have a can end turn. Let's also have a bool get can play card. And it's going to accept a card model that we'll refer to as card. And oh, right, this can't be a get because we're passing something in. So it's just a normal function. So can play card, what can we do in here? In this case, we're just going to return true. We'll just be like, yeah, you can play any card. It's simple as that for now. Okay, within our play card function, so first of all, we want to check that thing we just made. So if not can play card, and we'll pass in that card, we just want to return right out of here, so nothing else happens. When we're playing a card, we will take whoever the player is, and we will remove that card from them, which is that function we recently made, that all it does is looks for that card in their hand and removes it. So we have that. Then, in the case of this game, when you play a card, you're really just putting in the discard pile. So we can take our discards and we can go .add and we can add in card. Great. So it's been removed, it's been played. Technically, we could do this in any order, but logically in a game, it makes sense to remove the card before it's played. So we will do that. Then what we're going to do is, and I'm just going to stub this in. Certain cards can have what we'll call side effects. Playing, for instance, in Crazy Eights, playing an 8 allows you to sort of change the trump at that time, that kind of thing. So I'm going to create a future void function called apply card side effects. And it's going to take a card model of card. And in this case, we're just going to make it async, and we're not going to do anything. But we are going to remember to put it right here. So right when it's played, which can happen right here, we'll actually await the play card side effects, because that might be something asynchronous. Like I might ask the user for like, hey, choose what the new trump is, or pick a player that you want to apply this action to, that kind of thing. Right now, it'll do nothing. It'll essentially be instant, and everything's good. We also want to take our turn. Now we're storing something in our turns called action count. This is obviously playing a card would be considered an action, so let's increment that. And then we want to then notify listeners. Okay, so we have a play card. Now we need to actually work with it. So let's go to, we already have our playing card, I think it's called playing card, and you'll see we've so here's a playing card. We need a way to essentially make our playing card clickable, right? So the only cards that are obviously playable, at least in this basic game, are ones that you have in your hand. So let's go to our card list, and we've already kind of started by, we have this on play card function, which isn't being used. Like if I search for this, you're only going to see it in these two spots. So essentially, we want to kind of pass this function through. So I'm just going to get that started by going on play card, and we can just go on play card. Now this is getting an error because our playing card does not even know what that is. So let's figure that out. So we're going to have a final function on play card. And it's going to be a function that returns, just like before, we're basically just kind of daisy chaining, these functions to flow through. And then we want to go this dot on play card. And what we can then do in here is we want to wrap this around, I think around the whole thing. Let's wrap it around here. We're going to just put a gesture detector. and we can do an on tap. And what we want to do, because this could be null, let's just first of all check if on play card does not equal null, then we can just run on play card. And we put exclamation mark here because we know it is this, and it is giving me an error because it's expecting the card to be passed through. So let's just pass that through. All right. So this essentially will hit this, and then this essentially will hit whatever our card list is, and our card list happens to be part of the game board. So let's look at our player's card list, which is this one here, and we can have an on-play card now. Okay, so this is a function that card model will come through. And let's just for now do print card dot value or something, just so we can see if this is even working. Okay, so now if I click this and we scroll down, we should see a queen, 6. So we are playing, this is getting passed through all 3 of those things, and it is working. So, but what we actually want to do is, play that card. So we already created this. In our model, we have a play card. And the player we want to pass through is this player here, player 0. So just the same guy here. And the card we want to pass through is obviously this card. Okay, so that will call this play card, which will make sure that it can play, which right now is just returning true. And then it will remove the card. It will add that card to the discard pile. It will apply any side effects, which does nothing. It will increment the actions, and it will notify listeners, meaning the UI will update. So let's refresh. New game, and I will draw a card, and I'm going to try to play this card. There it is. It's in the discard pile now. End turn. Now we have no logic right now. In theory, I can draw many cards, and I can play many cards, and everything is good. But let's implement a little bit of logic here. So in our game provider, in our can play card, let's just look at if turn.action count is less than 1, we can play it. So this will require, only 1 card can be played per turn. New game. Grabbing this card, I'm going to just grab a bunch. And let's just see, I can play the 4, but I can't play anything else. But as soon as it goes around the board again, he's going to play, and then I can draw a card, and I can play again. So our logic is working fine. Similarly, let's limit the amount of draws. So can end turn. Where's our draw card? Draw card. So up here, let's put a bool get can draw card, and it's going to return turn dot draw count is less than 1. So you can only do 1. Now, we also want to check here now when we're drawing cards, if can draw card, or rather if not can draw card, will return out. So now I should only be able to draw 1 card. So I drew 1, let's try to draw another. It's not letting me, but I can end my turn, or I can play a card. I will do both, and I should be able to draw again. Yep, so everything's working. My bot's playing. Well, the bot's not fully playing yet. All the bot is doing is drawing every turn. So let's go to our bot logic again, and we can essentially do something here to make him play a card. So let's go. Let's just do play card, and we'll use turn dot current player, and then card. Now we could we could write some logic to randomly pick a card or whatever, but let's just take turn.currentPlayer.cards.first. Now, we also probably, in theory, it's possible, although with this logic, I don't think it is, that there's no cards in the hand. So let's just make sure we wrap this in a turn.currentPlayer.cards.length is greater than 0, or we can actually refactor that to is not empty. Then we will allow them to play a card. And the play card essentially does all these things, and will allow him to put it on the deck. Let's also, whenever this happens, kind of add a bit of an extra, an extra delay just to make, he's really thinking about playing. So I drew a card, I end my turn. Okay, and he decided to play that card because he can. Or she. There, 10 went down. So obviously the bot every time is just going to draw a card and play whatever card they have. Everything is working as expected. So yeah, this is kind of what I would say is sort of our framework that we have set up now for for playing a card game. The rules are dumb. This game is not fun. So what we're going to be doing next is actually, which I've alluded to a few times now, is converting this to an abstract class, probably adding some more helpers and stuff. But we're actually going to start overriding certain things, certain rules, such as can play a card might be a little more complicated, like, oh, you have to have, this particular suit in order to play this turn. We can add more logic there. We're also going to be adding stuff for winning the game, which in Crazy Eights would be, hey, you ran out of cards, game is over, you win, or the bot. We'll also be making our bot turn because the game will have some business logic of, in Crazy Eights, there's all these rules. So we're going to be implementing, a bit of a better AI. It's not going to be crazy, but enough that it can actually, in theory, beat you. And lastly, we'll obviously be adding in stuff for card side effects. So playing like a 2 requires the other player to pick up 2, that kind of stuff. So excited for that, and we'll see you at the next one. Okay, we are going to dig into creating some better game logic for a specific game rather than just, a drawing and playing card game. First off, if you pay attention closely, we are able to see the other player's hand, which is not ideal. It's only for a moment, but let's add some logic there. So in our card list, we have something called, we have the playing card here, and we have this visible. So there's a couple ways we could do this. But I think the best way is let's actually pass through a variable here. Actually, no, we can do this because we already know the player. So we can very easily just actually go player dot is human. Now this logic will fail if this became a multiplayer game and we need something that kind of tracks, that the player is the one, operating the UI. But if we were to do this now, and for instance, let's draw a card and end a turn, we should see that that card is blank. So yeah, just a little thing there. We could always, for debug purposes, turn this back on so we can see what they're doing. And in fact, maybe I will do that for the purpose of building this game. But just so you know, we have that option there. So now if I draw a card and my turn, we can see that person's card, and there they played it. Okay, I'm going to close a bunch of stuff because we're going to kind of start something new now. So we have our provider, which is in this folder called providers. I'm going to make a new one called Crazy Eights Game Provider.dart. And this isn't a widget, this is a class, and it's going to be called Crazy Eights Game Provider. And it's actually going to extend Game Provider. Oops, extends. Then let's open up Game Provider. And we're going to make this an abstract class, meaning it can never be instantiated on its own. It's meant to be inherited, and then you work with it that way. So if I do save now, you're going to see literally that error. Game provider is an abstract class and cannot be instantiated. So let's go back to our main.dart. And instead of doing game provider, we'll do Crazy Eights game provider. So that's one thing we have to do. Now we're going to see some other errors. Not showing up there, but in our either in our game screen or probably in our game board, wherever we have our consumer, basically, it's expecting it to be game provider, but let's make it Crazy Eights game provider. Now, if we refresh, we do want to do a hard refresh because that's kind of a dirty change. Okay, so we are seeing another instance, another problem here. Let's just see where we have game provider. Main, Crazy 8's game provider, that one's fine. Crazy 8's game provider. This is our class we just made. That's our abstract class. Oh, yes. Also, we have a instance of our game provider here, which needs to also change to Crazy 8's game provider in a couple spots. And everything else should work now, in theory. And we go back here, and there we are. Now, this will behave exactly the same way because of the way inheritance works. Anything that is a public method of game provider, so discards and new game and setup board and everything, you can call. I can basically call that from here. But the beauty is we can actually do some overrides of various functions. So for instance, let's take our setup board function, and we're going to make it a little more like how would a game be set up in Crazy 8s. So what we're going to do is actually do a loop. We want to, for each player in players, we're going to essentially draw some cards. So we'll await draw cards, and the player is P in this case. And we actually can, instead of just drawing one, we can do 8 because that's how many cards you get in Crazy 8s. And it should be good. Now, there's one little thing that is going to be a problem because really you can only draw cards on your turn based on our current logic here. So we're going to make another variable here called allow anytime. By default, it's going to be false. And we can go right here, can draw a card. It would, this, we kind of want to override this. So we can go if not allow anytime and not can draw a card, then return. So now if we are able to pass that over like this, allow anytime, true. So that'll kind of, it's basically not going to worry about calling this. Is this logic right though? Can draw a card. Yeah, I think that logic will work. Okay, so we have that. So that will, well, let's just, let's see this. So this is, oh, we forgot one thing. Whenever you're overriding a function in something you inherit, you put this override. This is like when you're, overriding the init state of a class, because init state's a function that's part of a stateful widget. So you can override it like this. And we didn't save a file, so let's save that. So now if we actually reload the game, new game, we see that we're both given 8 cards, and the deck is now less. So that's great. Now, one other thing we want to do after we do that is actually draw something to the discard pile. So we don't have a function for that yet. We could make it in here, no problem, but this sounds like something that many games could, make use of. So let's make that function, and I think it can go kind of after here, future void draw card to discard pile. So this is kind of like going to be similar to the drawing cards function, except it doesn't go to a player, it just goes right to the discard pile. And let's do this, an int of count equaling 1 by default, so we can draw multiple ones. This is an async function. And we'll do a draw. So we'll use final, we'll call it draw, and it equals await. This is very much like the functionality down here. And we can do service.drawCards, and we will pass in the current deck because we're doing it from the current deck, and the count will be whatever that count is, 1 by default. So we have that, and that's just drawing the card. Now we have to put the cards in the discard pile. So we can do this a couple ways. We can go discards equals and take whatever's in the discard and spread it, or we can just do it this other way, which we can just go discards.add all, meaning instead of passing in one item, we're actually passing a array, a list in, and we'll use that draw cards as that. So it's going to kind of combine that array. And of course, we want to, anytime these things happen, notify listeners so that our widgets rebuild. So then over here, we can go and draw cards to discard pile. And what do we want to draw? Count of 1. 1 is good. So we'll just leave the default. And that is good. Okay. Okay, there we go. So let's just see how that all works. We'll refresh. New game. And all that stuff happens. And look, that got taken from there. Draw cards from discard pile. I feel like one little thing didn't. I feel like we missed one thing here. Did that? Let's calculate this. There's 52 cards in a deck. We subtract 8 for each player. 36, and there should be 1 less. So there is some issue here. Draw service. I feel like we missed one thing. Right. So we had this line. We need to also remember in the draw card to discard pile, we also want to subtract whatever's in the current deck by. Now we can just do it this way, because when we do a draw, we get back the remaining. Okay, so one more refresh, and we should hopefully say 35 after all this. Yep, 35. So 8, 8, and 1. Okay, very good. Back to our Crazy 8 game provider. So we have like an override for setting up the board, because in Crazy 8s the game is a little bit different. What else is different? Well, lots of things. Okay. Yeah, so one thing we should definitely be thinking about overriding is, and I should be able to just type this, can play card, which I think is can play card there. And this will be this will return a Boolean. It's an override of this card model. So just kind of basically just copying this. Looks like we need to import this guy. And currently the default one is this, but when we override it, it's going to be using this. So we're going to have some logic in here to be like, can I actually play this card? Now, in Crazy 8s, there's a few rules. First of all, you need to, it's based on kind of like what the last card was played. So we want to kind of keep track of that. Now, we know it's the top of the discard pile, but not every game, uses, a discard pile kind of thing. So what I want to create kind of in our main provider is just something that we've already set it up. We have this thing called game state here. And this is just going to be a way where us as the programmer can kind of remember things and keep them in memory between turns and that kind of stuff. So what we can do is we're going to make a variable called can play. And we're just set it to false right off the top. And at the very end, we're going to return that value. And the reason we're doing this is because there's multiple conditions that can ultimately turn this to true. So we're just going to kind of go through the different conditions and set it to true if it can. And then when it gets to the end, we know we're good. So what I want to do is, first of all, we need a way to know what card is at the top of the discard pile. Like I said, we could just look at that by the top of the discard. But I want to kind of make use of this game state sort of thing. So we're going to go back to our game provider, and anytime we play a card, we're going to go game state, and we're essentially going to make something called, like, for instance, like last suit equal to whatever that card dot suit is, right? Now this gets a little bit tedious using strings like this because you might make a typo in one and everything will become a problem. And we could also, like, the game state could be like an object that has, properties like, card.suit. But the idea of this game state thing is it should just kind of work with every type of game. So we are purposely keeping it a little bit open-ended. But rather than just having strings, let's go to our constants file, and we're going to make a constant called, and I'm going to just start these with GS, meaning game state, and we'll call it like last suit. And we can really put anything here, but it makes sense to just kind of use like last suit or something like that, or even keep it the same. Really, this could just be a random string as long as it's, not, as long as it's unique, it'll be fine. And we'll do last value. So these are just kind of like the keys. So that here, instead of typing this out every time, we can just go like this. And we need to import that. So we can do that, and we can do gs last value equals card.value. So now anytime we play a card, this is going to replace whatever was in here at that given time. Meaning over here, we can do some things, and we can look at our game state object because it's a part of the thing we're inheriting, and we can check, gs last suit. And what we can, first of all, in this game, just to kind of solve all of our things right off the bat, if the last suit is null, or game state gs last value is null. So if these are null, meaning no card has been played, a card can't be played. Hopefully that never happens because we'd be stuck in a, I don't know what you could do at that point, but we'll have that in there to kind of protect us. The next thing we can check in Crazy Eights is as long as the suit matches, you're allowed to play it. So we can go if it equals card.suit. We're just going to set can play to true. Similarly, we can check the last value. If it's equal to card.value, can play equals true as well. Now there's a few other things. Let's add in if card.value is equal to 8, because in Crazy Eights, an 8 is wild, and you can play anytime. We can also say can play equals true. So in theory, at this, we could also just be returning true, returning true, returning true, and then returning false at the end. But I want to return the game's, not game state, but sorry, return can play. Just so that we can have more logic without just returning right away. Like there might be things where, okay, that was true, but then at the very end, maybe there's a condition that, but like, oh, but if it's the queen of spades, you can never play. So this just allows us to be more flexible with our rules, but feel free to kind of write your logic the way you want it. Okay, so that is cool. Now, one thing that's missing is in our setup board, we do need to kind of say, hey, that whatever that last card was needs to, we need to update the game state with whatever is at the top. So what we're actually going to do is rather than, so a couple ways we could do this, and I'll do it the one way first. So we drew the card to the discard pile. Let's actually await that because it is an asynchronous function. And then we could kind of take this same logic here and go like this. But instead of using card.suit, we can use the discard. Discard top is a property we have. And we know there's something in it, so we can just do that. So that's fine. That's going to take whatever's at the top of the discard and do it. But why don't we make a function that kind of that we've already like repeated the same code more or less a bit. So let's put this somewhere around, yeah, the draw card from discard pile, I guess. And we're going to just call this set last played. And we're just going to pass in a card model card. And essentially, I'm going to copy this, and instead of saying discard top, we will use whatever that card is, card. And then, so that is good. So that means instead of doing this, we can actually go set last played, and we can take discard top and pass that in. Right, and let's just make sure whenever we are calling this, we're notifying listeners, just in case. Similarly, where did we have this? Let's also do the same thing here. Set last card played to card in this case, and we can get rid of this. Okay, so let's see if this even works. So there's a 3 of spades. If our logic is correct and I didn't miss something, I should be able to play the 7 of spades. Oh, my turn. Hang on. Let's end my turn. Okay, let's just refresh. New game. Oh, right. Yeah, we do need to refresh for this. So I should be able to play the 5 of diamonds, which I can. Now, here's a problem is, oh, it actually maybe magically worked out. Okay, so now we do have to draw just because our business logic is that. Let me try and play the 7 of clubs. So I'm trying to play that. I'm trying to play the 2. I'm trying to play the ace. I'm going to play the queen. It does work. So it is this logic is working as expected. We could, we're following these rules. Everything is good. Okay, we also need to override some other stuff. So can end turn, for instance. Currently our can end turn, and I should be able to just go can end turn, boom. And we'll just turn this into a normal function. So in crazy eights, what is the rules for ending your turn? You need to either at least have drawn a card, or you need to at least have done an action, meaning playing a card. So what we can do is we can go if turn, and in this case, so because we're working within our sort of like sandbox of crazy eights provider that's extending this, we can actually no longer work with a private property. Like you can't even access turn, which is why we have those getters and setters and everything. But I can access, turn without that. So I can go to if turn.drawCount is greater than 0, or turn.actionCount is greater than 0. Then we know we can end the turn. Otherwise, we're going to not be able to end a turn. So that will kind of slightly change our logic. And the difference is, let's just kind of get through another one of these as work. So let me play the Queen of Hearts because it's the same value, end turn. Let's see. Okay, so now I can't end my turn, but if I was to, in theory, if I was either able to play or pick up, I should be able to. So let's just try playing. Yep, I can end my turn. And in this case, let's try just drawing, and look, I can end my turn. So that logic is working fine. Now, there might be something weird happening with the bot, because there's definitely some weird stuff happening with the bot. Let's fix that. Okay. So this bot turn is just like, hey, I'm just going to draw and I'm just going to play my most recent card. And it probably doesn't even do anything half the time because remember, if it can't play the card, it just returns. So let's override our bot turn function. And I'm just going to grab this and remember to override it. So the logic here is going to be a bit different. I do like, I do want to kind of add one of these awaits in. It's just fun. It makes it think that the player's thinking about it. And what we can do is let's loop through all the cards that the bot has. So in turn.currentPlayer.cards. So we're just going to loop through C, and we can check if can play card C, and that's going to use that same logic here. Then we will do stuff. So if it can play that card, we're going to await play card. And in this case, we're going to pass in this turn.currentPlayer. And just to simplify things, let's make something called P equal to turn.currentPlayer. That way we can kind of just call this P here and call this P here, and this would be C. And if the player was able to play a card, they're going to play it because that's just good strategy. Play it if you can, and then it's going to end its turn. And then we want to return out of this function fully because we don't want it to then go to the next card and continue. Now, let's say it gets through all of these and hasn't returned, meaning it can't play a card. Let's give another little, oh, I'm really thinking about this. I feel bad. And then we want to draw a card. So draw cards right there. And we got to pass in that player, and we got to pass a count, but the default is already 1, so we can ignore that. And then let's await again. They just drew their card. They're thinking. Now, because in Crazy Eights you can draw a card and you can decide to play that card, we want to then go and check. So if can play card. Now, where do we get this C from? Well, we can look at player.cards.last, because it's going to be the last one in their hand. Then we can go and await, and this would be p.cards.last, and we'll await that. And either way, at the very end, we're going to end the turn. And let's remember what end turn does. End turn.next. Yeah, and everything should just work. Okay, so now we have a smarter bot. Obviously, like, you could really blow this out and kind of like find out, okay, what card, like instead of just playing the card immediately, you could find a list of all the cards that are playable and write strategy on, different things. Like you might have, maybe you have like a 7 of diamonds and a 7 of spades. Well, if you have both of those options, you might want to look at how many spades do I have in my hand, because I probably would rather change it to a suit that is more obvious or more easy to play later. That's basic Crazy 8 logic. There's a lot more. So this function, in a proper game could probably be like the longest function in your entire program. But I think this is totally fine for learning purposes. Just going to play the first card it finds. You could also do stuff like randomize the order of your cards just so that it's feels a little more random. But this is totally fine. Okay, so we're restarting the game, and let's see if this game, even works. Wow, so I can't play anything. I'm pretty sure I'm going to try. Can't really play anything. So I'm going to draw. And I should see another card came, and we're just going to end our turn because we can't play. Okay, so I guess that I wasn't paying attention, but it seems like the bot maybe played. We will pay more attention this time. I should be able to play the 3 of clubs and end turn. Let's see what they do. So they played the king of clubs. Great. So our logic is working fine. Let's play the 10 of clubs. They played the 10 of hearts. Hey, this is great. I'm going to play the 10 of spades. Okay, 4 of spades. I can play the 4 of clubs. Hey, this is turning out to be a pretty exciting game. No plays for me yet. Now there's an 8. I can play this because we have that logic says can play 8s, but currently there's no way for me to choose a new suit. So I imagine it's just going to be spades now, which it is. So that was kind of cool that just worked. I can't play, so I'll draw, and I still can't play, so I'll end my turn. Okay, and look at this. End turn, and now we don't have any logic to be like, hey, the game is over, this person won, but we just got beat by our own AI, which I am equally excited and mad about, because that AI was not very good, but I guess the luck was not on our side. Okay, so yeah, next section of this video, we will be going into a couple things. One, we want to deal with these side effects. So for instance, playing a jack is miss a turn. Playing 2 will require the other person to pick up 2. So we want to do some stuff like that, as well as add some kind of like notifications, essentially like toasts, if you will, that kind of say things like, you have to pick up 2, that kind of stuff. And then we need obviously game logic for, hey, the game is over, congratulations, as well as it might be helpful to have something generic that kind of symbolizes like what kind of card is playable, like what is trump right now, if that's even the right word in Crazy Eights. So we'll catch you on the next one. All right, so in the game of Crazy Eights, there are some rules we need to think about, and we're going to cover those in our side effects. So we have this function in our primary provider called apply card side effects, which right now does nothing in our base game. But let's put that right over here along with an override, so that this one is used when we're playing Crazy Eights. Okay, so there's a few things that we want to account for. One is if an 8 is played. Another is a 2. Another is a jack. And another one is the queen of spades, right? Those are the main ones, at least I can think of. When you're playing with multiple, usually 4s is also, switch directions, but we're only having a 2-player game, so we're not going to worry about that. So let's start with 8 since it's crazy 8s. So whenever the apply card side effects is played, we have access to the card. So the first thing we can check is, if card.value is equal to 8, and value is a string. So we need to do it like that. And this is where we will essentially allow the player to pick an entirely new suit. So in order to do that, we need to kind of create like a widget. Now, this widget should only show up if the player is human. So let's keep that in mind. So if turn.currentPlayer.isHuman, we want to do something. It'd be something like, show a picker. Otherwise, what we want to do is kind of like allow the bot to randomly, pick one. So what we'll do in the inside this 8 is let's actually create a variable of suit called suit, and it's just gonna be null at first. So technically it's, I guess, this. Shit. So we'll have that suit there, and in the case of the bot, for now, let's just set suit equal to like suit.spades or something. Okay. Then, in the case that it's a player, we need to essentially allow them to pick something. So we would be using, I'm going to use like a show dialog function here, which we pass in the context. Now, this is an interesting challenge. We don't have access to context in our game provider because this isn't a stateful or even a stateless widget. It's its own thing. There are some good ways around this though. So if we go to our main.dart, we can actually create a couple. I'm going to create both of them now, right at the very top actually. We're going to make something called our navigator key, and it's a global key of type navigator state. And this will come in handy in a bit. But we also want to have a global, root scaffold messenger key. And it's also a global key, but it is of type scaffold messenger state. And what we can do is we can actually apply these within our material app. So I can say navigator key is equal to navigator key, and scaffold messenger key equal to scaffold messenger key. Root scaffold messenger key. Now, because these are just public variables in my main.dart, we can actually access them. So instead of putting context here, I can take my navigator key that we just made, navigator key. So it imported it. You'll see if I command click it, it's going to bring me to that guy there. And we want to say .current context. And technically current context is nullable, but we know it's not going to be null because we know the application's booted before it ever gets here, so we'll just put an exclamation mark. Then we have a builder, and we don't have to really pass anything in, and we are going to be creating a widget essentially that represents that, and that's good. So I'm just going to put like container for now, just so we can finish this up. And one other thing we want to do, barrier dismissible. I want it in this case to be false, because we don't want anyone, this isn't something you can, an alert you can cancel out of. We're not even gonna have a cancel button because you have to pick a suit. There's no way around it. So we're gonna show that dialog. Now, what we can do is we can actually await this, and the dialog, which we haven't created yet, can actually return a suit to us. So we can just set suit equal to whatever gets returned from this. And that will mean that this gets set, which we'll build that in a minute. And what we can do is we can't really set the last played card, but we can take our game state object and use the GS last suit and make it equal to suit. And then that will make everything really, really nice. So we need to build this, whatever's going to replace this. So we'll call this the suit chooser modal. So we're actually going to make a whole new folder here. New folder, we'll call it modals. Actually, this it's still a component. We'll just put in the components. And we'll call it suit chooser modal. dart. Let's start it with a stateless widget, suit chooser modal. Okay, so within here, we want to actually, well, we need to import this, and we're actually going to return an alert dialog, which is one of the options that this builder is expecting, as well as, probably other. I mean, I imagine you could actually probably use any stateless widget or even stateful. We'll give it a title, and it'll be a const of text saying choose suit. And it also needs content. And here we're going to have a row of all the different suits. We have some children. It's going to be great. And then we'll have some functionality that happens there. So let's figure that out. What are the children actually going to be? Well, we need, and we can put this right in our build function. We can have, a list of suits. We'll call it suits, and it's equal to this. Now, what I'd like to do, just to make this a little more type safe, is let's actually create something that only this class at least needs right now. We can always move it out if we don't, but we'll call it like suit option. And it's going to have a suit value and a color of color. Okay, so we have that, and we need to construct it. So suit option. Now this isn't a widget. This is just kind of like a data model. So we're going to do required this dot value, required this dot color. Sometimes it gets rid of the closing guy that I had, and there we go. So I like to use the underscore here because I don't want any other files to be using it, and it also is warning me now this isn't even being used. Well, we're about to use it. So final suits is actually going to be a list of suit options. So we'll set it there so that everyone is happy. And it's going to have 4 different suits, right? So the value will be suit.clubs, for instance, and color will be colors.black. Okay, let me just see something here. Yeah, so there we go. Now we can actually do this a little bit. We can actually go and do this. We could say suit to color, and we could then pass in, oh, sorry, this should be suit to color, and we can pass in the suit.clubs. That's, fully defined for suit. Oh, I thought it was. What? Static string. Oh, suit to color. This is not part of, right, suit isn't a model. So this could be, card model dot suit to color. So that's one way to do it. However, we could also just do it right in the constructor, aka let's not even require a color to be passed in, and we can say this dot color equals card model dot suit to color, and we can pass in this dot value. I think I'm doing something wrong here. So, what I did is instead of making this final variable, it's a late variable, so it can be assigned in the constructor like this, and then we just do color equals card model suit to color, which means this actually gets a lot simpler. We're just really going like this. So we would have hearts, spades, and what's last? Diamonds. Okay, so now we're going to take our suits dot map, and let's just remember to make it a list at the end, and we'll call this S, I guess, or we can just call it suit. And what we want to return from here is we're going to do a text button on pressed, and we'll worry about that in a minute. But the child is going to be text, and we're going to similarly, we want to get what the value, the string representation of that is. So we can actually do that here too. We could do string late. It'll be a string, and we'll call it label. And let's just say label equals card model dot suit to Unicode, and we'll pass in value again. Yeah, that's totally fine. That way we can actually just go suit.label. So now we have a text button of that, which is going to take the Unicode, and we want to make sure it's color. Inside text, we'll do a style, text style, and let's make its color, suit.color, and let's make the font size like 32 or something rather large. Okay, so that's kind of it. The only thing we have to worry about is on pressed. So because it's going to be an alert dialog, we can actually, when we click one, we can do navigator dot a dot of context dot pop, which will just dismiss it. But the pop, you can pass in an arbitrary value. And in this case, we want to pass in maybe suit dot value. So that will return like either one of these enums, right? One of the club, hearts, spades, or diamonds, which means over here, we actually are conforming to that. So let's save all. And instead of here, we actually want to use the suit chooser modal. And this could be a const because we're not passing anything into it. And if we now get lucky, we can, if we had an 8, we'd be able to try it out. What we could do is temporarily, and sometimes I like to just copy a whole line, and if card.value equals 8 or card.value maybe equals 7, let's kind of like allow a few different things here. And we'll just see. Now, the 8's the only one that will be allowed to play at any time, so we might have to make a change somewhere else, but let's see, we might get lucky. We do have a 5, which will allow us to play, but I can't play a 5, so let's just wait till we hopefully can test this out. Now I can play a 5 by following the rule, so I should get a modal popping up, which I do. So I tried to play the 5, choose a suit. We want to change it to diamonds, parse. Enter. Now, in theory, if everything is right, our AI should either play another 5, which they don't currently have, or play a diamond, because we just changed it to diamonds. Let's see. Did not work. Okay. I wonder why. Game state. Oh, I wonder if we're just missing. It could be because we didn't notify listeners. Let's throw a notify listeners at the very end anyways. Suit, game state, last suit equals that. And then let's see if we can do this again. It doesn't look like we have anything close. So we have a 5. That's the only one that would work. I can't even play a 5 yet, so let's just end turn. King, ace, ace. Okay, I should be able to play a 5 because it follows that, and I should get the suit modal. Let's change it to one that they have. They have hearts. Let's see if they play a heart now. End turn. Oh, they played a 5, which is also a fine roll. Okay. Let us pick up. And do I have anything? No. This kind of testing can be a bit annoying. We could write things that kind of like seed our hand with very specific things for these tests, but whatever. Let's refresh again. We'll be more careful next time. Okay, so we have a 7. We have a 5, so we have a few options. What do we go down to? 5, 6, 7, 8. Okay, so let's just wait until we can play one of our cards. 10, sure. 6. Oh, we have an 8. Hey, that's perfect, because we can play an 8 anytime. Okay, so I'm going to do 8, and let's see if they, we could make this a diamonds, because this would be it's going to loop through this way. So let's make it, let's do something different than a club. Let's do a diamond to see if they play this 9 of diamonds. End turn, and they don't. And I think I know why. I think I know exactly why. Apply card side effects. We want to go to our game provider and find that. So this gets called here. Yeah, it's because look, set last played actually happens. So what's happening is we're applying it, we're setting that state to the suit, but then it's setting that last played. This needs to actually happen after. and then we should be good. New game. Okay, I got an 8. I got so many 8s. We got 2 8s. So I'm gonna play play this and make it spades. And let's see if they play the queen of spades. End turn. And they do. Okay, so our logic is fine now. It's just an order of operations kind of situation. Okay, so we have that. Now, like I said, we could make this AI logic better to choose, a suit that they have. Let's make it not the best logic, but let's actually take whatever turn.currentPlayer.cards.first.suit. So it's going to take whatever suit they have first in their hand. This could be way smarter. Like you could be like, oh, if I have a 2, I want to make it that suit so I can play, or I want the suit to be whatever I have the most cards in. Doesn't really matter. But yeah, this is good. Okay, so that handles our thing. Let's also remember to, and I can just erase this line and put that one back as it was. And we don't really need this comment anymore because I think these comments are pretty obvious. Okay, so next we can go else if card.value is equal to 2. So this would be, oh, someone, this is like a pick up 2 sort of thing. So in this case, let's do, we want to await draw cards. And now I'm not the one that wants to draw it. It should be whatever the other player is. So I can go turn.other player, which if you remember, all this is doing is getting the opposite of whoever the current one is, which works totally fine for a 2-player game. If we were trying to make a 4-player game, we would need a modal to be like, hey, pick a player or something like that. But we will await that. And the amount, not just 1, but we want to do 2. And we have to remember to do this allow any time because it's not their turn right now. And we have to tell our game, like, still allow them to do it even though it's not their turn. So that's good. That should just work. And let's see if we have any 2s. Let's just start a new game. Maybe we'll get lucky. He has a 2. Oh, there's a 2 on the top, which we're not handling like any reaction, any effects for the one there. Let's just play around and make it diamonds. I really want a 2. Maybe I should be drawing then. Okay, well, that worked. Look, they played a 2, smart bot, and I just got 2 cards. So that's good. But I imagine a fast-paced game, you might be like, wait, what the heck just happened? Where these cards come from? I'm not paying attention. So I think we need some kind of modal of some sort or like a toast, a snack bar, that kind of thing. So I'm going to go to my main game provider, and let's go to the bottom because it's kind of like a utility thing. We're going to make something called show toast, and it's going to take a string of a message. And let's allow the toast also to we can control how long it shows up in seconds, and we'll just make a default of 3. And in the future, we might also want to have some actions have some of our snack bars to have some kind of action. We'll make that nullable. We won't make use of that now, but maybe there's like an undo button or something. I don't know. So now what we can use is that, remember we made that root scaffold messenger, which we kind of need because we don't have context here. So we can use our root scaffold messenger key, .current state. And again, we know that this exists. We could do a little bit extra logic here to make it super safe, but I can't see a world where we don't have a state because you're never going to call this at the start of the game. So show snack bar, and we want to pass in a snack bar. So we're going to construct that right now. Content will be text of whatever the message is that was passed through. We also want a duration of, and we're going to use duration seconds of whatever seconds was passed in, default of 3. And we'll also put an action just in case we ever wanted to make use of an action. So we'll put a semicolon, and there we just have a show toast, meaning in here, we might want to go something like show toast and do, and we can just say drew 3 cards, but we can get a bit smarter than that and actually go, turn.other player and say dot name, because they have a name, has to draw 2 cards. All right, so let's see if that works. I didn't get any 2s. Our friend here got a 2. So if we can kind of keep it to clubs, we can see if it worked. Oh, I can play a spade. Okay, let's just play the game. Jack of spades. That's something we'll be handling soon. 10 of clubs. Okay, so in theory, if I keep it clubs, because of our logic, this should be the next one that gets played. 2 of clubs. So there you go. Tyler has to draw 2 cards, and I did. Amazing. So now we have that. Similarly, let's do the logic. Let's get rid of our 2, and we're going to do the Queen of Spades. It's very similar. So I'm actually just going to copy this. Queen of Spades is 5 cards, and we're going to say 5. The only thing we have to change here is we obviously have to make this a queen, but we also need to make sure card.suit is equal to suit.spades. So this is checking, yes, is it the Queen of Spades? It's queen and it's spades, then we'll do that. We'll test that one later. Let's get our last one in. If card.value is equal to, I think it's just Jack, spelled like this, then we need to miss a turn. So how do we miss a turn? Well, it's actually very simple. We can just go our turn.next turn, and it'll just reset everything over. Now we probably want to toast here as well. Turn to other player, misses a turn. Misses a turn. That is sad. Okay, so there we go. Like I said, if you had multiple people, we could use for to change directions, but we don't. There's no really changing direction when there's 2 people. Okay, so let's try and play a game. Let's just play it. Okay, 9 of spades. Let's start by testing out our Jack. There we go. Tyler misses a turn. Why did I miss a turn? There might be some turn.otherplayer.name. Is this player's name Tyler? Or let's find out. We go to our, I think it's just in our game board where we initiate the game. Or no, I think it's in the game screen. Oh, wait, what? Yeah, I'm human. Oh, yeah, okay, so the order of this matters. So we should be saying like this, misses a turn and then doing the next turn. Otherwise, the next turn will make me, I think that's pretty obvious why that didn't work. Okay, so, but it did work. That person missed a turn, I think. Let's see, am I able to play? Oh, this is weird. I can't end my turn. Turn.next turn. Okay, let's start over because we made that change. Okay, so I have a Jack of spades again. That's good news. That's good news. Queen of, I have 2 jacks, so we can test this for real. So end turn. Okay, Tyler, wow, just gets me with the Queen of spades. Look at that, 5 cards. Let's play the Jack. Bot misses a turn, which means I should be able to play again. But then I don't know why my next turn is not showing up. Next turn, index plus current player, draw count. We have a notify listeners. So does this mean I can just keep, so there's obviously some bug here that I can just, I can keep playing. I wonder why. Let's see where this is being called. See, this is fun, debugging. Apply cart. Okay. So what happens here? The action count is plus set last. Let's play card. I wonder if we have to. Okay, so we play. Yeah, I feel like we have to when they. So we should finish the turn. Can end turn. So I think what we should do is actually call end turn really quickly. But then it's going to, and that would do the next turn, but then we almost need like a function that will do this without, because as soon as we end the turn, it's going to do the turn next turn, and then the bot's going to be able to play. So we almost need just something that's like, skip turn or something. And we can do turn dot next turn. We essentially want to call this twice, I believe, and then notify listeners. So it's kind of like this, but skips this and then goes to another one. I think that will work. So we'll just do skip turn. Okay, let's restart. Hopefully we get some jacks again. And we're almost there. Okay, we have a jack. We just need to make it happen. So let's change it to hearts and see if they hopefully play a heart, which they should. Oh, end turn. Okay, let's try. Jack gets played. Bot misses a turn, then I should be able to play. Boom. Okay, we're back. So just some weird order of operations sort of thing. Now, can we win this game? I can draw, and I cannot play. 10. Eight. So this was played, and my guess, because of our stupid logic, is that we have no indicator, which is probably the next thing we're going to do is an indicator of like what the current trump is. I'm guessing it's hearts because they did this. Now we can't even play if it is hearts, but let's just check my logic because I have every other suit. So yeah, it's definitely hearts right now. We'll have an indicator in a moment, meaning I have to draw. And I draw, but I still can't play. Okay, let's make him pick up 2 because he's getting pretty close to winning. And now hopefully he plays. He's not smart. Obviously he shouldn't have played an 8 right now, but that's okay. He made the suit spades based on what I can see. So let's put a spade. Hey, we were right. Okay, now hopefully, obviously he can't play, but he can play 8, and he would have made it a spade, which is a problem for us, and we are going to lose this game. Boom. And Tyler has to draw 2 cards. That's a good way to go out, Mr. Bot. Okay, we're getting creamed over here. I feel bad. Good bot, good bot. Okay, so next thing, let's have something to indicate what, which really only solves the edge case when an 8 is played by a bot. But let's figure that out. So in our game board, right over here, we are going to put sort of like this bottom widget kind of thing. So let's actually start with the business logic of this first. So what I want to do is in our root game provider, because this can be used by any games, we're going to make a new thing right here. It's going to be a widget. It's going to be allowed to be null, and it's going to be called bottom widget. And this is going to keep it really generic because you might want to, different games have different, different things. Like maybe you want to show the points or something here. Who knows? And in our bottom widget, so we have that. Let's also make a function, maybe right here, void set bottom widget. And it's going to take a widget, which will also allow null, so that we can pass null in and just empty it again. And we'll call it widget. And we can just go bottom widget equals widget. And we want to notify listeners whenever that changes. Okay, so so that is cool. And we should be good there. So then in our game board, we have our deck pile. This is in that row. I'm going to put this whole thing also now in a column, and main axis size dot min. And before our column closes, let's just do something like if model dot bottom widget does not equal null. We can actually just inject in the bottom widget. Model dot bottom widget. exclamation mark, because we know it's not null. Meaning, whenever we are, whenever a card is played, we want to kind of set that suit there. So let's build a way to do that. I'm going to make kind of like a helper on top of this helper. Void, and we're going to call it set trump, which requires a suit to be passed in. And what this is going to do is actually call set bottom widget with a widget that we're going to build right now. And it's just going to be a card widget, like literally the built-in card, not our playing card, with some text. And we will use that helper that we have, card model dot suit to Unicode of whatever suit that is. And we want to give this text some style. Text style. Let's make it pretty big, maybe like 24. And color, we want to use that card model dot suit to color and pass in that suit again. And looks like we're missing just a semicolon there. And we can probably add another comma there to make it a little bit more friendly. One more there. Sweet. So now what we can do is we can use this set trump. Remember when we made that set last played in our game provider? Set last played. Whenever we're setting last played, let's also set trump. And we can just pass in card.suit. So this, when set last played is called, we can set trump. And whenever set trump, it's going to set that bottom widget to basically like an emoji symbol of the suit. Okay, so let's see. This should work without even a. As soon as someone at least plays something, which is, oh yeah, I basically lost the game, but it's still going. Okay, hopefully someone can play. Okay, you know what? We're just gonna restart, new deck, new everything. So there you can see right here, we have this little indicator, and that's just reminding us of what trump is. Now, let's try and force him to play an 8, or maybe we'll get one before then. So let's just, whatever, do a jack, because we can. Do an ace, end turn. 10 of clubs, cool, club still shows up, queen of clubs. 8 of spades, he played an 8, and now he turned it to spades, I believe. Oh, maybe not. Okay, so there's something wrong there, and it's probably because our 8, right, we need to obviously in here also go set trump to whatever the suit is. And we know it's not null. In fact, we don't need that. It will never be null once it gets through these things. So let's just start a new game and make sure we're good. Do I have an 8? I don't. Does he have an 8? He does. Okay, if we can get him to play hearts, we should be okay. 10 of diamonds. You can pick up 2. There you go. There's your 2. Looks like he's getting close to wanting to play that 8. And if I, in theory, don't play, I mean, I could have played something, but he should play the 8 now. So he's changed it to spades. And we should probably actually, another thing we could do is do a toast to be like, this person played spades, or change it to spades. So we'll do that in a second. But in theory now, I have to play a spade. Okay, so that little indicator is working great. So let's do what we said. Let's do a show toast. And we'll just do turn dot current player has changed it to, and we are going to essentially take whatever that suit is. Now, to present it in a pretty way, we will use our card model dot suit to string and pass in that suit. So now whenever it's Nate played, it'll say, whoever the current player name has changed it to this. Do we have any 8s? Not really. So we'll see that happen at some point. Okay, we're almost there. We're almost there. This is coming together fairly nicely. Okay, I think one more thing we could do is some kind of indication of whose turn it is. Generally, there's like, some kind of bar at the top of your screen that kind of, represents the two different players. So let's build something like that. So first of all, let's call it player info, maybe, .dart. And this is going to be a stateless widget, as most of our widgets have been. Player info, cool. Import this. And we're going to just pass in that turn object. We'll call it turn. And we're going to make it a required key, a required value, this dot turn. Turn needs to be imported. There we go. Okay, so what do we want to do with this? This is essentially going to be a bar that's across the screen. So let's just start by, giving this thing, maybe it's a container with sort of a colors.black, like really dark black. And for now, let's just give it a width of double.infinity and a height of 32, just to kind of get it placed somewhere on the screen. So go back to our, I'm just going to have a lot of things open. So Command K, Command W, and let's open back up our player info, but let's also open up the game board. So we kind of have this stack right here, but let's wrap this stack in a column. And I think that'll work. And essentially, let's just put the player info, within the children, player info. And turn is going to be model.turn. And let's just make sure, make sure turn isn't null. Because can turn be null? I think it can. It's late. No, it should be fine. It should be fine. Okay. Now this is going to make stuff kind of weird because now that it's in a column, it's not, the stack is no longer taking up all the room. So what I want to do is then wrap this stack in an expanded widget. And then it kind of goes back how it was. This is getting a little bit squishy, as you can see, but we have this player bar here, which will, we're going to have more stuff. So yeah, looks good. Let's give this, I'm going to get rid of the height now because it'll just take whatever height's inside of it. And let's put a row here. And let's actually wrap that row in some padding. Just the default of 8 sounds good to me, or maybe even 4. That should be fine. Now inside our row, let's first of all give it some children, and we want these, there's gonna be 2 items in this row, so let's make its main axis alignment dot space between, so that they essentially are on either sides of them. And what we can do is for our children, we can take the turn dot players dot map. So we're going to loop through all the players and create an item in this. And let's just remember at the very end to convert this back to a list because it's very easy to forget that. Okay, so first of all, let's just know, is this the current player? And we can just make a little variable here. If turn dot current player, is current is equal to turn dot current player equaling P. That way we can, show things a little bit differently. Getting all of these like warnings because it doesn't like us not returning anything, but we're about to return something. And in this case, let's return a container. And inside the container, it's going to have some decoration of box decoration, and it's going to have a border radius. And let's do border radius dot circular 3. This is just going to kind of give it a little bit of rounded edges. And we're going to use that is color by checking if they're current. We'll use colors dot white. Otherwise, colors dot transparent. Okay, so that's kind of the start. Now, obviously, in here we need a little bit more. So we'll give it a child of text. And what we can put in here is the player name, p.name. And let's just see if this is even all working. So there we have that. Now it's kind of squishy, so let's throw some padding around this guy. And I think just even like 3 is going to be enough. There, that's a little bit better. And we see that guy over there, but we can't see it, and that's because we want to change its style. So let's do style, text style, and it's going to have a color based on the same thing. If it is current, We'll use colors.black, otherwise colors.white. Let's also just in general kind of give it a font weight of font weight dot maybe like 700. Dot width 700. So now we should be able to see both. One is kind of like highlighted, one isn't. Now something else we could do is in where we did its name, which is p.name. Let's turn this into a string with string interpolation. And let's put the number of cards, for instance, that they have. So we can do p.cards.length. And then we'll kind of see, oh, I have 8 cards, bot has 7. Obviously, I'm doing not doing as well. So that's great. Obviously, this could be improved, and you could have avatars and all that kind of stuff. But this should, as I finish my turn, for instance, we should see now it's the bot's turn. Okay, now it's my turn. Okay, and the bot plays really fast, but sometimes it takes longer. There you go. So now we have an indicator of that. Lastly, before we maybe experiment and have some fun, I want to do one sort of final video after this of showing like, okay, we have Crazy Eights. Now, what if we wanted to make a different game? How could that work? But the last thing we kind of have to deal with is the idea of winning. So let's go to our game provider, our base one. And essentially, we want something to kind of represent the game being over, right? So what we can do in our base, this feels like it could live maybe around here. Yeah, I think this is the best spot. We're going to make a bool called game is over. Okay, and it can actually be a getter. And we're just going to return false in here. In fact, actually in this one, let's return if, what is our, if current deck dot remaining is equal to 0, or we can is less than 1, and current deck can be null. So basically, like in our base boring game, the game is over when when this happens. So that's fine. And what we should do is in our play card function in our base one, right before the notify listeners, after the side effects, we can go if game is over. We can call something like, and let's just call it like finish game. And finish game will be, for now, let's just put this near game is over. Void finish game. And we can literally just go show toast game over. And we'll notify listeners. We could do other, manage other stuff here, like, collect all the cards or whatever, and whatnot. But that is fine. And let's just go to our can, where's our can play? We can just go if game is over, return false. So if the game's over, you can't even play a card. So that's all and good, but for Crazy Eights, obviously that's not how, the game doesn't end when the pile's gone. And that's, something we would also want to handle is, okay, what happens when you run out of cards? Well, all the discards get shuffled up and go, and that is something I'd like to do, but we'll keep it simple for now and assume the game will end before that. So let's go to our Crazy Eights game provider, and we're going to override. We're going to be overriding at least the game is over. So let's grab this, and we'll put it kind of at the bottom. And I'm going to put it before the AI bot override. Okay, so how do we check if game is over? Well, all we really care about is whoever is just playing right now. So if the turn.currentPlayer.cards is empty, if they don't have any cards left, we're going to return true. Otherwise, we'll return false. And now we've conformed to that. So that's all good. We can test this out, but I'm going to make it a little bit easier for us to test. So in our setup board, let's just deal 3 cards to everyone. And It'll be just, in theory, a faster game. Not necessarily, but in theory. Okay, so I can't play, but I can, wait. Okay, there's something that, yeah, something went wrong. Oh, I think I know why. If game is over. Okay, if current deck dot remaining is less than 1. Okay, why can't I do anything? So we made some logical error. I'm assuming it has something to do with this can play card. So let's just see if that is in fact the case. Oh no, it could be, wait, I'm trying to draw a card. Okay, let's just refresh and see. Yeah, it's not letting me, we'll get to that in a minute. Let's just see if we can at least get the trigger of ending the game to happen. It looks like it's going to happen very soon. There we go, game over. Now there's nothing saying like this person won or that person won. So we could, we could very easily in the game is over, that's the game is over. What's the other one? Finish game. We could just override, this and do show toast, and we could say, because we know it's going to be the current player, turn.currentPlayer.name wins. So that's just going to override that, which means we need an override. And this one won't be called now. This one will, because specifically in this game, we know when this is called, that it is the current player that is the winner. So I do want to see what was going on, though. There seemed to be something weird. I wasn't able to pick up a card at the start. So let's try and debug that, because debugging is fun. So I can't pick up a card. I can't play a card, obviously. I wonder why. So let's kind of step through exactly everything that happens here. So in our draw card, oops, draw cards. Let's find our function for draw cards. So passes in a player. So I'm guessing, let's just put a print statement here. You can literally just say hi or something just to see like when I'm clicking this. So it is getting there, but I bet it's not getting past here. See? So I think it's something to do with this logic here. If not allow, it could be something to do with our can draw card, turn.draw count. Oh, you know why maybe? Let's print can draw card. Let's just print turn.draw count and see if it's, yeah. So okay, that's why. At the start of the game, so we just didn't notice this before. Draw count is actually 6 because this setup board is probably not happening in the right spot. So we should actually set up the board before we create the turn, basically. And I think that will solve our issue. And I'll get rid of that print statement. Okay, so I should be able to draw now. No, it still says 6. Turn equals that setup board. Oh, yeah, setup board. Set last played, and then I mean, we could easily just let's just see if this will work, and it's probably a better solution. Turn dot draw count equals 0. Turn dot action count equals 0. Let's just see if that even solves our issue. Looks like it did. Everything's good. Not sure why that's happening because the turn gets made after, and when you create the turn, it's a new game. Setup board. Setup board gets called. I mean, this is a totally fine solution. There's probably something more obvious that I'm just not thinking of right now, but this works. Where essentially when we set the board, because cards were drawn, we're just going to set the draw count and action count to 0. Okay, so we're good on that. And yeah, I think we got we tested everything. There's probably some little minor bugs in here that we'll find, but yeah, this is good. New game gets changed to spades. Boom. I can play, and I can change it to hearts. So we see Tyler. Oh, instance of player model has changed it to hearts. That's hilarious. Has changed it. This should say current player dot name. And did we mess that up anywhere else? Name, name, name. No, I think we're good. Let's just save that. So I've changed it to hearts, and I'm ending my turn. Okay. Now I can't play. Oh, I got a queen of spades. That's going to come in handy. Maybe. Let's really try and screw this guy. He's going to play the 10 of spades now because I can see his hand. Queen of spades, you got to pick up 5. Oh, yeah. End turn. 6 of spades, end turn. Change it to clubs. That's too bad. Can't play. You can skip to the next video now. This last part of this series, I wanted to just do sort of a full overview of everything, just so you can kind of see it all in one place, as we obviously built all these pieces separately. Followed by, I want to just do a quick experiment of, okay, how could we use the core stuff we've built to actually create another game? We likely won't finish that entire game. It's just kind of to show like the workflow of working in this way. So just as a review, we will start kind of right at the start of the application. And I'm going to just clean up some stuff as we go, because certain things, such as this, is no longer imported, because we're importing Crazy 8's provider instead. So our main.dart is very simple. It has its main function, which ultimately calls run app, as every Dart Flutter app does. But rather than just going right to our app, we are actually wrapping it in a multi-provider that allows us to have multiple providers. I did multi-provider because we, in theory, might have different games, and it's just a way to have multiple ones. Also in here, we have our public navigator key and root scaffold messenger key. This is ways that we can get access to the context, as well as the scaffold globally in our app, which is necessary when we're trying to do something outside of the widget tree. Simple app, and all it does set some variables here and loads the game screen. Game screen is also quite simple. It's a stateful widget. And it basically, all it does is sort of have an app bar that has the new game, new game button, which essentially when pressed just creates these 2 players. Now this is something you could easily update and create some kind of dialogues to collect the players' names and whatnot, but we've just kind of hard-coded these for simplicity. So nothing really crazy going on here. And in fact, this could probably be reconverted back to a stateless widget, but I'm not going to worry about that. The body of it is the game board. And the game board itself, UI-wise, is our most complicated screen. Essentially, all it does, and all it does is quite a few things, is it is a stateless widget, which is cool. Even though there is state in here, we're relying on consumer. So in the main build for this, it is actually wrapped into consumer of our Crazy 8's game provider, which this model is the most important part of this. This is essentially a representation of the instance of our provider. So Because we are doing a because we're wrapping this consumer, this will rebuild every time that our model tells it to rebuild, meaning calling something like change or notify listeners. So within here, we do have, and I'll show you in the UI, let's just make a new game. We do have a column, and that's so that we can kind of have this bar at the very top. Then there is a stack, which contains all these things within here. Essentially, there's an align that controls this. There's an align that's centered for this whole area, and a line that's bottom centered for this. This itself is also a column because we wanted to put this button in here. So that's kind of the layout of it. Now, within the most important one, arguably the most important one, the middle one, it has a gesture detector around this deck here, which essentially calls our draw cards function, and it is the deck pile. Then we have just a little bit of a spacer, and that's where we have the deck pile here for the ones that we can see, the discards. So two different deck piles there. Or sorry, that's why deck pile and discard pile. Deck pile is okay, we can't see, they're turned upside down, and discard pile is actually a stack of multiple cards, which we're passing in based on our model. We also have this little thing that, if our model has declared a bottom widget, we will, if it's not null, we will display it here. And that's actually, in this game, this sort of trump indicator here. We also have a top center for this and a bottom center for this, which this one's a little more complex because it is not an AI player, so we need some kind of functionality such as ending the turn. All right, and that is also part of that column here is this this card list, which takes a player attribute and goes through. So let's take a look at, for instance, card list. So card list itself has a few parameters, the size, and that's just something so that we could update the size as a ratio. Right now, the default's always 1, but we could override it to make the cards bigger or smaller and so on and so forth. Also a player, which is this sort of model that we've created. They have a name, they have a Boolean whether there is human, and they have a list. You'll notice this isn't final because we want to be able to change it, but there is cards that we instantiate, just an empty array, and a couple helpers to add cards, remove cards, and just a getter to check if it's a bot, which is really just a reverse of is human. And then we have a function on play card, and you can kind of see that when we pass this in, we have this function. It is expecting a card model to come back, and we then go to our model, which is our game provider, and we run the function play card by picking, we want to use it's this player, and this is the particular card. That function itself actually just gets passed through, which is pretty common in Flutter. You make a function that doesn't even do anything here, but just gets passed through to the next thing. So this is a list view builder of in the direction of horizontal, which allows it to scroll this way if we had enough enough cards. And I imagine I can emulate that just like that. And it loops through and all the cards that that player has and essentially returns a playing card. And the playing card itself has a card model. Now the card model is, there's an image, there's a suit, which is actually just an enum of suits, hearts, clubs, diamonds, spades, and a value, which could be like, it's actually a string of 1, 2, 3, 4, 5, all the way up to 10, and then spelt out Jack, Queen, King. Also in here is just some helpers to convert things between that string name to our enum and the other direction. We also have some stuff to make the Unicodes or the emoji symbols for each of these things, as well as something for suit to color, which if it's hearts or diamonds, it's red, otherwise black. Okay, our playing card essentially has an on-tap event on it. If the function passed in is null, it doesn't do anything. Otherwise, it does do it, and it passes back the card. And that's just so we can kind of conform to this idea that ultimately, 2 layers higher up, we want to be able to call a function. It gets passed, that function gets passed in through here, passed in through here. If you tap it, it gets passed back, and it gets passed back. And this is where it actually ends up doing anything meaningful. And within here, it's pretty simple. It's just a container we have a constant for like our card width and card height, so that we can, work with that and keep the ratio the same. And it multiplies that by that optional parameter of size, so that we could have bigger cards and smaller cards, by passing in 0.5, for example. Um, a little bit of border radius just to give it that nice, curvy edge. And essentially we have something whether or not the card's visible, which will declare it to show a network image of that card's image, which is just the URL. And of course, if it is not visible, we just use this component we made called card back, which this is something you could improve very easily just by putting maybe a gradient or finding an image of the back of a card. This is kind of ugly, but it works. Okay, so that's that. That's our card list. Now, that kind of covers, I think, like a good chunk of the UI. There's obviously some other components in here. We have like sort of a modal to choose a suit, and you can go back and watch, how that all works. That's when Trump is declared. But UI-wise, that I think covers most of it. We've talked about some of the models. The card model, for instance. There's also a deck model, and that represents the entire deck. All 52 cards. And we instantiate it to get that going. There's also the idea of a draw, which is when you actually pick up one or many cards, and it essentially references a deck, but it just tracks kind of like what cards are in there and how many are remaining. Or sorry, how many cards did you draw? And this will be a list of actual cards of that card model, and then remaining in the deck. We also have a player, which we looked at, and the idea of a turn. A turn tracking just tracks all the players involved. What turn number are we on? Who's the current player? And also we have sort of a getter for the other player, which just kind of looks for the first one that isn't. Again, this will work no problem for a two-player game. This would have to change, the logic would have to change a lot if you were looking at having more than two, but not a terrible challenge. We looked at the screens. There's really only one, and that's pretty fine. The other two pieces where I think we probably spent the most actual time in were our providers and our services. So we did build a service called Deck Service, and this works with this API that we went into right at the very start, which is the Deck of Cards API. It's a nice API for, I think, really just for learning purposes was its purpose, because again, we could have fairly easily built this whole thing with, memorizing all the cards, keeping them in memory, as opposed to working with an API. But the purpose of this whole Flutter tutorial was really to kind of like show all the pieces of a general app that you would build, which generally has an API. And that's why I chose to use it. Ultimately, this is a pretty simple file because we did a lot of the heavy lifting in this API service. And this is kind of just a way to work with HTTP while, kind of not dealing with the intricacies of it. Because as you can see, the code here is pretty clean. It's just, okay, await HTTP GET, pass in the path, not even the whole URL, but just the path, and then some parameters in a format that programmers like to work, which is basically like a map, right? As opposed to when you actually do a GET request, you are writing things like, param1 equals blah, blah, blah. Then you have to do like an ampersand to get the next thing, and so on and so forth. And that's really tedious and ugly. So our API service sort of had a helper to get the URL, and that's you can pass in parameters and it loops through and builds that query string I was just showing. It also does some stuff to make sure there's no double, some extra slashes and whatnot, and then it parses the URL. And then our HTTP GET function, which is what we're interfacing with right here, it expects a path, and it builds that URL based on the path and the parameters that we've passed in, if anything. Then it does the response, and it JSON decodes it, and we actually run it through a UTF-8.decode just in case the API we're working with isn't super friendly. This will just clean up strange characters and that kind of stuff. So yeah, that's kind of the service, and all it really did, we have something to get a new deck and something to draw cards. And it's a pretty cool service because basically our sort of like business logic of what's in the deck is handled server side. And there is an advantage to that because if you did make this a multiplayer game, it makes it a lot harder to cheat when there's sort of this general center of truth that you can't really hack unless you really know what you're doing. So that's our sort of like services, and then we have providers. So we built something called the game provider, and this is our root provider for any game that we might build, such as Crazy Eights. And this on its own, we actually, we worked with this for a while, and we made a very simple game of just, okay, you can draw a card and you can play a card. But it has things in it that, remember, stuff about the deck, what players are here, what's in the discard pile. So it's this sort of like generic game state object that any of your games could make use of just to remember, okay, what maybe happened last turn or what's trump or that kind of thing. We have some functionality to create a new game, which goes and gets that new deck with our service and just kind of resets everything and runs this setup board function, which in this case does nothing, but we can override this in our specific game. Yeah, and then some other helpers like drawing cards right to the discard pile as opposed to a player's hand. Some stuff that just set what was last played, which is helpful in many games. It's important to know what was last played. Some helpers of like, okay, can I draw a card? We don't need this print here. Something to actually draw cards. And this one's we'll go over this one a little more in detail. So essentially draw cards, we pass it a player, which is required because it's not inside these brackets right here, these braces, because we need to know where to draw it to. And then we have a count of 1 as the default, but you could in theory pass it, I want to draw 8 cards, 10 cards, 52 cards, whatever. We also have this thing, allow anytime, because we do have this logic to make sure that someone can't really cheat. Like you're only really allowed to draw the card if can draw a card is true, except in the case where you override this and say this is true. That is good for like, in the board setup or something like, I just played the Queen of Spades, you have to pick up 5. Our program needs to not follow the general rule that you set with can draw a card. Because we're overriding and enforcing it. Yes, this person has to draw these. Then we do the draw, which is an asynchronous function because it is working with this API with the service that we made to draw cards, and we pass in what the current deck is and the count because we might override that from 1 to something else. Then we take whatever that draw is. Draw has something called cards, which is a list, and we actually add those cards. And this was just that helper function we made where we just take cards and we combine them together, spread and get the new ones, and then we have a new list. We also increment the draw count. So, draw count plus equals 1 if the default is true. And that's just part of our logic that can be used. For instance, if the game requires you to draw a card every turn, we want to, we would imply that rule. And then we also take the current deck and we just set its remaining amount to whatever the remaining of this draw is, which is just something we get back from that API. And then, of course, we have to remember anytime we want the UI to reflect something new, we want to notify listeners. And that's so that our consumer that's wrapped up in our game board right here, it knows that this function should rebuild. Some other helpers here. Play card is somewhat similar to draw cards, except you're playing the card, which does a bunch of stuff here, like incrementing the action count instead of the draw count. We also do this thing called apply card side effects, which is empty in our base game provider because this game is so simple. There is no side effects. But in Crazy Eights, for instance, we override it to do things like, if it's an 8, let them change trump. If it's a 2, someone pick up 2. Some helpers to check if you're allowed to end the turn, something to actually end the turn. And after we end the turn, if the current player, because this is going to increment the player, the current player is a bot, we run this function called bot turn. And bot turn in our base is really just something where, okay, he waits for half a second, or she draws cards, default of 1, so draws 1 card, waits a bit again. And then assuming that the cards aren't empty, we wait for another second because the bot's thinking, and we play that card. So this game is very boring. Essentially just picks up a card, plays that card, picks up a card, plays that card, and so on and so forth. Then we also want to, assuming the logic is like I can end turn, which would be true in this, then it ends turn, which essentially calls this again. But of course, unless you have 2 bots in a row, this wouldn't get called the next time. So it's kind of like the flow with a bit of the very basic AI. We have stuff just to finish the game, which really just shows a toast in this game over, because there's not really even a winner in our base game. You can't, and in fact, I don't even think this can get called because we don't have any logic. I don't think we even have any. Yeah, if game is over, well, let's see. Right, so this, yeah, if you played long enough and all 52 cards, basically if you have 0 cards remaining, it will call that game over. So this game can end. And then we do have a helper for showing a toast, which works with that. Because we're outside of our build tree, we can't have access to context in the same way. So we're using that root scaffold messenger keys current state to show snack bar. And we show this snack bar, which takes takes a required message and amount of time. And we could even pass in a snack bar action, maybe an undo button or something. So that's our game provider, and this is kind of like our core engine. If anything, it's a game engine for a card game, and it's not. This could get a lot more. You could add a lot more functionality here because we're not. We made Crazy Eights is a pretty basic game. If you're trying to make something like Euchre, you would probably end up not just making your own provider for it to inherit this, but also probably adding more functionality here because there's a lot more going on with a game like that. Okay, lastly, our Crazy Eights game provider, which essentially inherits game provider. So this has access to everything public that game provider has. So you'll notice some things are underscored. We can't, from Crazy Eights game provider, actually access this right here, but we can access the getter, which we've made. And this is just a common way of doing things to kind of protect certain variables that you don't want other things to access, but still giving them a way to access a reference to it. So what we did in here is every time you see override is we're actually overriding something that game provider has. So for instance, setup board, which was an empty function in Crazy Eights, we loop through all the players and we draw. This should actually be 8. I think we made a change near the end just to make debugging a little bit faster. And this is a case where we want to do that allow any time because there's not really a current player right now. It would return false, being like, this one's not allowed, you're not allowed to draw a card now. It's not your turn, but we're overriding it to say, yeah, nope, just let it happen. And then we actually draw a card to the discard pile because that's just something that happens in Crazy Eights. One gets flipped up from the top. And then we want to set last played, which is just kind of like setting in memory that the 7 of spades, for instance, was played, which actually does these things like uses game state object to keep track of the suit and track of the value. Okay, then and then we just reset the draw count and action count to 0 because although action count probably doesn't matter, draw count technically at this point would be 6. Or now that we've changed this would actually be 16, and that would kind of mess up things. So we just reset it back to 0. We also override the getter for can end turn. And in this case, if your draw count is greater than 0 or your action count is greater than 0, you can end your turn. The bot can end their turn, or you can, player can end their turn. And that's because in Crazy Eights, you either have to play a card or you have to pick up a card, or you can do both. You can pick up and then play, or stupidly, you could technically play and then pick up. But the whole point of the game is to get rid of cards, so there's no real reason to do that. Then we have something for overriding can play card because it's a little bit different. I think in the base one, it's actually just, yes, you can play that card, return true. But we kind of check some things like, okay, first of all, if for some reason there's no last suit and no last value, which in our logic, that's not really possible, but we're just kind of protecting ourselves. We say, you can't play because you just can't. We check, okay, if the card suit is equal to the last suit played, you can play. Also, if the value is the same, and those are just rules of Crazy Eights. You have to follow either suit or follow the numeric value. Or we have this thing that, hey, if the card value is actually 8, you can play it because you can play an 8 anytime. It's a wild card. Our side effects, this was a pretty fun thing. Remember the side effects in the base is nothing actually happens. But here we check some things like, okay, if it's 8, and if the player's human, we're going to show that sort of chooser modal, which is just like a pop-up that comes to choose one of the 4 suits. Otherwise, we actually have a little bit of AI logic here. When it is the bot, we just look at whatever their first card is in their hand and set it to that suit. This logic could be a lot smarter, as we talked about. We also set, because when this happens, when you play an 8, you pick a new suit. We have to remember to set the game state to that suit, and we have this helper to set trump, which basically is just the little thing that indicates that hearts is trump right now. And then we show a toast, and that's a helper that we already looked at, where we just pass it a message, so the current player name has changed it to whatever that suit name is. We also sometimes, things for two, which makes the other player, draw two cards, and we have to do, allow any time, because technically they're not, allowed to draw a card because it's not their turn, but, we need them to do that. We have something similar to two, where if it's a queen and it's spades, they draw five. That's the queen of spades. And then we have something where if it's a jack, that player misses a turn, and we had a helper function called skip turn, which essentially just increments the turn twice. Okay, that looks good. That looks good. And again, we want to notify listeners when things happen so that UI can update accordingly. We also overrode the game is over. If the current player at any time has no cards in their hand, the game is over. And we have this finished game that we override to actually take, instead of just saying game over, we do kind of have a winner. We know that if it's because current player is what we're checking, we know that whoever the current player is the winner, and we can show that toast. Now, there's more we could do here where, we say want to play again or whatever, but I don't think we need to worry about that. Okay, then bot turn, we also made a little bit smarter. Again, this this function you could make this 1,000 lines of code and make it really intelligent. But basically what's happening here is we do a delay, and this is just to give the idea that, hey, the bot's thinking about stuff. It just makes it a little more fun and not happening instantly. Then we loop through all the cards in the bot's hand, and if the bot can play the card, we go and we play the card and we end turn. And we return out of this because we don't want it to keep, this returns out of the whole function. We don't want it to keep looping. Now, if it gets through all of this and this hasn't returned, we do another delay. He's like, I'm thinking. Then we're like, okay, you got to draw a card. And then, okay, I'm thinking. And then it checks to see if that last card, because when we draw a card, it gets appended to the end. We can just be like, hey, if I can play this one, then play it. Because you're allowed in Crazy 8s to draw a card. And if it becomes something you can play, you play it. And then we end turn. Obviously, this could be smarter where, hey, let's find, first of all, before just returning out of here, let's make, a list of all playable cards. Cool. We know with three, let's say the bot has 3 cards they could play. Then you write some logic to kind of be like, oh, okay, what suits are these? Hey, I have more clubs than diamonds. I should play a club because in Crazy 8s there's a good chance that on my next turn, it'll probably be a club again, rather than changing the suit prematurely and then being like, oh, now I can't play. Just basic logic there. And yeah, that's kind of, in short, really what this project does and how it works. And I hope, kind of as much as I tried to review things as we go, I hope this sort of final review kind of makes everything click if it hasn't yet. Again, this is basic. This is not. This is nothing. This could, like I mentioned, this could be a lot better. There's also some, some slight missing things, I'm sure. And I'm sure even, if you download this off GitHub and you play with it, you might still find some bugs because I'm sure it's not perfect. We kind of, built this live. But I think it's a cool, a cool way to think about things. And yeah, I think it's interesting that we are something that could completely be client side. We are integrated with an API, again, just for learning purposes and to kind of deal with asynchronousness because when you have an API, nothing happens instantaneously, and that's why we have all these awaits. So I'm going to just to kind of give people a starting place of, hey, I want to make this game. I'm in and this is a pretty blind coding experience that we're about to get into right now. I did have a lot of this tutorial lesson course, whatever you want to call it, pretty planned to an extent. But this is now me being like, hey, I just watched this tutorial and I want to make my own game. So let's just play around with that. And I apologize if mistakes are made, and they will be. So what I'm going to do first is make a new provider. And the game that I have in mind is called 31. It's a pretty fun game. 31 game provider.dart. The idea with the game, before we write any code, is players always have 3 cards in their hand at any time. So they're dealt 3 and they have 3. And they can choose to pick up from blindly from the from the deck or from whatever card is on top of the deck. And they always have to discard at the end of their turn. So the logic's a little bit different in Crazy Eights, in the sense that in Crazy Eights you can have 8 cards, 9, whatever. In this game, when you finish your turn, you always have 3 cards. And the intention of the game is to have 3 cards all in the same suit, that are as high as they can be. Meaning like a 5 is worth 5 points, a 6 is worth 6 points, a 10 is worth 10 points. Now a Jack, Queen, and King are also worth 10. They're considered just face cards, 10. And then aces are actually worth 11. So the idea is, in an ideal world, you actually get 31 points, which is you having an ace and 2 face cards or a 10 in the same suit. But the cool thing about the game is you can essentially, if you think you are winning, if you think you have a good hand, meaning maybe you just have like 28, but it's pretty early on, you can essentially forgo your turn, and that's called knocking, and you are essentially, then the other player gets one more turn to try and do it, and then the hands are revealed, and everyone, whoever has the most points wins. So I'm going to try and try and make this happen for us here. There will be some changes we will have to make to Game Provider, some additions, because for instance, we don't currently have a way to draw a card from the discard pile, only from the main pile, but that should be fine. So let's get to this. I don't know how long this is going to take. This might turn into a 2-parter video because I know we're already 30 minutes in. But let's just see what happens. So we're going to make a class called 31 Game Provider, and it's going to extend the Game Provider, and we're just going to do that. And that's our starting point. And we are going to go into our main.dart, and we're just going to add another change notifier here, or change notifier provider, and to create, and it's going to do the 31 game provider. That way it's, and this is why I want to use multi-provider, so we could support multiple games. Then in our game screen, I believe, we have a Crazy Eights game provider, and now in an ideal world, if you were building a game where it's like, oh, I want the user to like, we have 10 different games, you can choose it. The logic here would have to change. You wouldn't want to just hard code whatever, but it'd be pretty simple to do, to kind of have a menu screen, and then the actual provider itself gets passed to the game screen of which game you're wanting to play. But we're not going to worry about that at this time, or probably ever. So we're just going to go 31 game provider, 31 game provider. And then I think in one more place we need to do this is in our components, our game board. So this, we just need to say it's not actually a Crazy Eights game provider, it is the 31 game provider. So now I'm just going to do a bit of a refresh here. Now what's interesting is this is just going to start working, in the sense that because we're inheriting this, we're getting that sort of base game that we made, which the base game, again, is I draw a card, I could end my turn, he draws a card, he can decide to play, and our AI says, yes, you should play, and so on and so forth. I'm going to draw a card. So now because we're just inheriting this and not overriding anything, we're back to the core game provider, which is a kind of nice, clean slate. So I think the first thing that's worth overriding is sort of that setup board. And in VS Code, I can kind of just start typing, and it knows, because I'm extending this, that there's something, and it'll actually kind of throw all the boilerplate in. Now this is an async function, so we do need to add that. It wasn't smart enough to do that for us. Now, if we just kept this like this, essentially, like, we're overriding it, but we're using the super. And what this means is, like, it's going to use, this version of setup board. Obviously, that's not what we want to do. And in fact, VS Code gives us this warning being like, don't override to do a super method invocation with the same parameters. This should be helped say in setup board. All we want to do is like do a, show a toast of like, welcome to my game, and then still function as it normally would. That's a good, that's a good use case for this. And we would see if we did, refresh this game, or we should see when the setup board happens, welcome to my game. So that's kind of cool. But obviously here we want to do this a little bit differently. I'm going to open up the Crazy Eights one, because it is going to be kind of similar. And I'm just going to copy and paste, as we like to do in programming. So instead of drawing instead of drawing 4 cards or 8 cards, we are going to draw 3. We are going to do that allow every time. We do draw 1 to the discard pile. So there are, I picked this game for a reason. There are some similarities. Where something like euchre or poker, we'd be looking at a lot of differences, but nothing you couldn't do, I don't think. We don't actually, in this game, there's no concept of like, we don't really care about what someone played last, as far as I can think. So we won't worry about putting that in, but we do want to make sure we set the draw count back to 0, just so that stuff works properly. So there's our setup board. And if we were to make a new game now, we should see we all have 3 cards and that 1 card goes here. So that's the first override. The next thing we would want to do is, what else do we override here? Can end turn. Sure, let's just do that. So in this game, can end turn, it's a getter. And I don't know where that semicolon came from, but sure. We want to, so you always have to draw and you always have to play. So if turn.draw count is equal to 1 and turn.action count is equal to 1, return true. Otherwise, you're going to return false. Now, similarly, and I'll put this in the same spot, can draw card. Oh, that's where it came from. Right. Okay, can draw card. So I can do it. I'll do this the common way first, and then we'll do a faster way of doing it just for fun. Draw count is less than 1, return true. Otherwise, return false. Now, this could be cleaned up in a much simpler way where we can actually say return turn.draw count is less than 1. So this is going to return either true or false. If the draw count is less than 1, it'll be true. If not, it'll be false. So that just cleans that up. And in fact, we can also do something similar here. We can literally just do this. And this is just, nice and clean and less lines of code to maintain. Basically, it's going to return true if these 2 conditions are true. Otherwise, it will return false. We can also do can play card. I don't know why I'm not getting my, I thought it was, yeah, can. I don't know why sometimes VS Code is like, I don't want to help at all. So we'll just type it ourselves. Override can play card, which is a bool. Now this one's not a getter because we have to pass in a card model of card. And in terms of can play card in this game, you can, it doesn't really matter what the card is. We still have to conform, to this, but it doesn't actually matter what the card is. All we really care about is we're going to return if turn dot action count is less than 1, we can play a card. Now, also in this game, although I don't know if there's a hard rule about this in the actual game, you're supposed to pick up before you discard, which just makes sense because why would you discard and then be like, oh, I picked up something else? So let's just make it easier on our players to enforce that obvious strategy. So we can also say if turn.draw count is equal to 1 and turn.action count is less than 1. So it's basically like, hey, you have to pick up first. The draw count has to be 1 in order to play, but the action count must be less than 1. So let's just see with this sort of logic and a quick, I don't have to rebuild. I know that hot reload's great, but I like to kind of just do things clean sometimes. So in theory, I shouldn't be able to play a card right now based on this logic here. So I'm going to try to play a card. No. But I'm going to try and draw a card. So I get my 4th card in my hand. And then I am going to, now I should be able to play a card. And strategically right now, these face cards are pretty high. I should probably get rid of one of these. I can see the other player's hand, which obviously we need to disable that. But it's kind of fun to know what they have. So, and in this case, it doesn't really matter what I play because they have both of these. So I'm just going to play that. And then it should allow me to end turn. Now, this might be a little bit weird because we haven't written any bot logic yet, but it actually is kind of working as expected because our bot logic is just, hey, I'm going to pick up a card, I'm going to play a card. So they're kind of just randomly playing. They are going to lose, but maybe not. I've been beat before. Okay, so can play card is pretty simple. What else? Apply card side effects. There's actually not really any side effects in this game because it's really just like this is a game where you're just trying to collect, the highest cards. So I don't think we have to worry about that. Let's do game is over. Game, yay! This time it got me back. You got me, VS Code. Okay, so this this is actually going to require a bit of extra work. So I'm just going to return false for now, and we'll come back to this because we kind of have to do something interesting for that. Finish game. We'll worry about doing that after. Let's keep our bot turn as is, and just so that we kind of have it stubbed out, I'm gonna put it in here, and I'm gonna just do what we talked about before. We're just gonna call the super one for now. So we have it here, it's ready to go, and I'm just gonna like print something like bot turn just so VS Code doesn't complain, and I'll even make like it say to do. This is a fun thing to do. Speaking of to dos, in VS Code, it's nice to kind of do to do update bot logic. And the reason for it is you can go in your problems tab and you can actually see all of your to-dos, update bot logic. It's just a nice way to track things without searching for the word to do. And it even, at least in my color scheme, makes a to-do actually looks, different. See how it was like bright orange. So just a fun fact. Okay, so we got, this is actually coming together okay, but there's some new stuff we do need. For instance, we need, yeah, actually, let's start with that. So in 31, not only can you pick up from here, you could actually pick up from here, which is interesting. So we need logic to do that. We don't even have that in our main game provider at all. So let's get our main game provider open, and let's also get our game board open. So you'll see we'll have the discard pile. So discard pile doesn't have any functionality with it. It's kind of just a visual thing, but we are going to improve that. So we're going to have a final function, which will take a card, the function will have a card model return back from it, and we'll call it on pressed. And then we want to go this dot on pressed. Now this should actually be a optional function because we might not pass that through, so we'll keep it optional. And then now that we have an on press on the discard pile, let us wrap maybe the whole container in a gesture detector. I like gesture detectors because they don't affect anything about the layout. When you wrap things in like a button, something like that, like, you get padding and you get all this stuff. But gesture detector is just kind of like a raw, hey, this area is a hit spot. So we'll do on tap, and in here we'll go if on pressed does not equal null, then we can call on pressed, and we want to actually pass in a card. And for the purposes of now, we should just be able to take cards dot last, because last one will be whatever's at the top. Now, do use curly braces for all flow control. Okay, I will do that then. So now we have this function that'll do on pressed, and that way over here, we can then in our discard pile do a on pressed. And now we could have, I guess we could have actually just similar to here, we could have actually just wrapped our logic in here, but I kind of like the idea of having it on the object itself. So for now, let's just print. So this will take back a card, and see how it's kind of, Dart's really nice, or at least like VS Code interpreting Dart is really nice because it actually knows that this card is a card model, and that's only because we've passed in, the function will return a card model as the first parameter. So that's pretty cool. So let's just print that and save. And in theory now, if we go back to our terminal and click this, did I not save everything? Print card.suit. Let's make sure we're good. There's oh, you know what? I probably do have to at least do some kind of state change, but let's see. So let's see if I pick this. No, I'm not getting anything. Let's find out why. So let's just start at discard pile. I like to kind of start at the very top or the bottom, I guess. And let's just print a test, and let's see if like the click is even working. So it's not even working on this. I wonder why. Gesture detector is wrapped around the container. Am I in the right thing? Discard pile, yeah. Yeah, why is this on tap not working? Okay, let's just, I'm going to just try something here, but I actually just don't understand. There's a gesture detector around the discard pile. Is there something that's like overlapping it? Let me just make it a bit bigger. That's very strange. Gesture detector wrapped around the container. Then there's a stack. Oh, maybe the stack is overflowing the thing. I'm going to just do one quick test here. Wrap with widget. There's a cool widget called ignore pointer, and you can set ignoring to true, which might actually just solve what our issue is. That was the issue. So our stack is, these things are on top of this container. So we could do that. We could have also decided, oh, let's put the gesture detector around the stack, and that's in fact what I'm going to do. So we'll wrap this with a widget gesture detector, and I'm just going to pass this whole guy here on tap, and let's just get rid of this one because we don't need him. Remove this widget. I think one of the things I love the most about like VS Code and Flutter is that kind of stuff, like because it's so tedious to, okay, I need to erase this, but then I have to scroll down here to get rid of this. Like the refactoring tools are like make writing UI amazing. So now I should be able to click here. Maybe. Wow. Is it because the playing card is? It's probably because the playing card is there. Now I could wrap it around the playing card, but then we're gonna get like so many gesture detectors stacked. So let's let us just do what we were gonna do anyways, and yeah, yeah, we'll just do it this way. So wrap with widget, and oh wait, why did it? Oh, okay, wrap. You know what? I like the way we had it. We're almost back. Okay, ignore pointer. We're just gonna do it this way because this was working. I can click this. I get test. I get suit of diamonds, so we know that's good. Okay, we're back. We're back. Okay, so on pressed, we want to call a function that we haven't made yet in our main game provider. So we have like play card. We have like draw cards. So we're gonna make a new one called, and the best way to put it, probably here, I think is good. We're gonna make it a, I don't think this will have to actually be a feature. It's gonna be a return void, draw cards from discard. And we are going to optionally have a, what do we use? Not count, but I think amount. Int amount, and it's going to be 1 by default. And we do need to pass in a player, which will be required. And I will do follow the same convention we've been doing. And let's just make, was amount what we've been calling it? Count. We want to do count. Let's keep it consistent. So draw cards from discard pile. So what would we want to do here? Well, we want to, first of all, get the first X cards, 1 card to whatever the count is, and remove them from the discard pile, and then give them to player. And I think we also want to increment the draw count because it's still like a draw. Now, if your game had more complicated rules where like you're allowed to pick up 1 from the discard pile and 2 from the normal pile, like you'd have to like be tracking something else. But for this game, this is exactly what we actually want. Okay, getting the first X cards. So we have access to discard pile. So first of all, let's first of all, even before this, make sure that this can be done. So we're going to make another helper. It will return a bool. Can draw cards from discard pile. And actually, it won't be a getter because we want to pass in this count. and we'll just do it like that. So we want to just check, we can just make this a simple one. If return discard dot length, if discards dot length is less than count, or sorry, greater or equal to count, we're returning. So if there's more or equal to, we are allowed to draw. So let's grab that. If, and we can say if not, can draw cards from the discard pile, count, return false, or just return. So we're not going to even let it happen. Very good. Okay, then in this case, we want to get the first X cards. So we can take our discard pile dot remove, I think remove range, and let's just make sure. No, that won't work because, is it like pop? Okay, I think I got my head around this. So what we're going to do is make a variable called cards, and it's going to be equal to the discards, and we're going to get range, and get range basically returns, these items from the start to the end. So the end will always be the discards.length -1, because arrays start there. And then the start will actually be discards.length -1 minus whatever our count is. So let's just see, first of all, what that would be. And make sure this is working. I will, let's actually, just to debug this a bit better, cards.forEach, and we can print element dot value. That should be enough for us to know that this is working as expected, hopefully. So let's save that. Make sure, oh, we forgot a semicolon. And we should get the hot reload. And if we go back here, if I click this, I get suit dot, oh, but that was our function before. Oh, because we're not actually calling this yet. We want to go model dot draw cards and discard. And actually this value for us doesn't even matter. And draw cards and discard, and we got to take in the model.current current player, model.turn.current player. All right. So now if I click this, we get a error here. Yeah, okay, so we have like an index error, discards.length -1 minus count. Oh, you know what? I think get range, the first, maybe it's not actually start and end. I bet it's one's inclusive. Well, let's just see. I switched it so that, well, I won't explain it until I know what happens. Okay. Okay, we're going to look up this function a little bit more. Get range. So, this is part of programming, is knowing how it works. To provide the range, the start and end must be valid at the time of the call. A range from start to end is valid if 0 is the return interval behaves like a skip start. Get range. Okay, so we can look at this lovely example they put here. Colors.get range 1 through 4. So 1, so it is the, the whatever our index is. That part is a normal thing because it says it comes back with green, so it would be 0 would have got us red. And then 4 is returning, so 0, 1, 2, 3, 4. Get range. 0, 1, 2. 1, 2, 3, 4. So I think, yeah. So it's like it's indexed and then not indexed by 0, something like that. So that means that this is correct, and let's see. Yeah, still not. Just a dumb little logic error. I had like minus the count, then -1 again. We don't want the -1. So we're just taking whatever the length is minus count, and then discards.length, meaning it'll be going to the last one. So that makes sense. So we get our cards and we put that in memory. Then we should be able to just go discards.remove range, and we can use the same thing. And in fact, to do this, then let's just do final start equals this, final end equals whatever we had here. That way we don't have to type this out so many times. So this would just be start end and start end here. So this just puts these cards into memory, because when you remove, there's not a way to be like, give me those cards, my cards equal. This actually, remove range actually returns nothing. It's void. It just destructs those from that. So first we need to, before we remove them, we have to like know what they are. So we're keeping them in here. We can also get rid of this now. Then we need to give them to the player. So we can go player dot add cards, and we can pass in cards, right? The argument can't be assigned to the parameter list card model. What? Iterable. Oh, I think I have to also go get range and then go dot to list to make it a list. Otherwise, it's just an iterable. So now it's a list. Then we add the cards. Then we want to increment the draw count. So turn dot draw count plus equals, and we should just use whatever this count was, right? And I think we can, I'll keep those comments for now in case we need to fix this. So now, in theory, if I pick up this card, oh, and we have to remember to notify listeners. So this is going to do some funny things, because now the state it did work, but it didn't. So let's just start over, new game. And I should be able to either pick up this or pick up this. I'm going to obviously pick up this because that's what we're doing. And we're good. Now I can't end turn, but if I play something, I can end turn. There we go. Now, can I still draw? I can't. Can I pick up this? Yes, I can. So we need to also make sure that can draw. Let's also go if can draw a card, or we'll just do if not can draw a card, return false, because we want to, that same rule will apply in this case. So now I will restart. And we will, we have some cards, everything's good. Let's try picking up this card, and I can't end my turn, but if I play this, I can end my turn. Cool. Now, something else, trump doesn't really matter in this. So let's actually, in our game provider, have sort of like a, I'm just finding a good spot to put this. Where do we have trump? Set trump. Let's have just a getter called show trump, and it will return a bool. And it's going to return true by default. But in our specific game, we can override that too. And let's just do it here, because why not? Show trump, and we're just going to return false. So we're overriding that. This is the shorthand version of it, and it's perfectly fine. We could, do that in a few places, I'm sure. Then we need to actually make use of this. So in our a couple places we could do it. I would say we have sort of like our yeah, let's do it right in the UI, because it is a UI thing. So we'll go to our game board and bottom widget. And you know what? I'm going to actually change this, not show. Instead of calling this show trump, let's just call this show bottom widget and return true in this case. That way we can go if bottom widget is real and model dot show bottom widget. Now we have an error, and that's because in our 31 game provider, this is no longer a thing. There we go. Then we'll save everything, and because it's false here, we shouldn't see that anymore. But if we went back to Crazy 8s, we would. because it will just use the default. Okay, finally. Well, not finally, but so we have picking up and drawing, or picking up and discarding. Our bot doesn't do anything useful, but he is following the rules, which is good. Let's just see if stuff's working. I pick this up. I'm going to discard that and turn. Okay, I think we got most of it together. The last thing is, I think it's the last thing. We just need a way to essentially be like, oh, this person wants to propose ending the game, meaning, and then we have to like count who has the most points. So I will, because we're hitting the hour mark now, I'm going to continue that in the next video. All right, one of the final pieces of the puzzle is to allow a player to choose that they're happy with their hand and they want to finish. So we're going to need to add another button, but we don't want that button to be something that is there in every game. This is specific to here. So I think what we're going to do is make a, in our game provider, we're going to create something, and it'll be a list of widgets. List of widget, and it will be, we'll call it like additional buttons. And it's by default just going to be something like this. So that's all good. Now, what we want to do is in our game UI, wherever we have that new, not new game, but is it end turn? End turn. We're going to, in this row, we're going to want to add those buttons. So let's see, that's the column, this is the row. So what we could do is we can then, we can do a spread. There's a few ways we could do this, but we can do a spread operator here and actually go in additional buttons. Now this has to be model.additional buttons. And let's just see, first of all, what that does for our game. And we had an error because I didn't save both, but no problems there. Now, this might not be the best way to do this because we're not really in a widget tree. I'm curious though if it will work. And we might actually have to, and in fact, yeah, instead of a list of widgets, we're going to actually create something. And I'm going to do it here for now, but we might move this around. And it's going to not be a, it's going to be a class called a, we'll call it like an action button. And it's going to have a label, which is a string. So final string label and final function. And it just be a final function with no parameters called on pressed, we'll call it. And then we want to make sure that when this is constructed, we are requiring this dot label and requiring this dot on pressed. And I got rid of my lovely stuff there. We forgot a semicolon, and then we're good. So rather than actually having a widget here, let's return a list of action buttons, which means this is now going to not work because we're no longer widgets, but we can then map over these and make sure we convert it to a list after. And we will, we'll call this button. We want to actually return a button that has, we'll just use that same thing, an elevated button. Elevated button on press. We won't do, or on press will be whatever that button dot on pressed is. And its child will be a text with whatever the label is, right? So this will allow us to kind of have, aside from our standard button, we can have multiple buttons here. So we do that, and we have to save this. And we get this little issue here, and I think that's just because we made some change and I didn't save both files at the same time. But let's find out. Okay, great. So if we did go into our additional buttons now, just to test, let's make this a little bit different. Let's put in a action button, and its label is going to be test, and its function is going to be, we'll just kind of like print hi. And we will save that And I'm just going to make it a little bit cleaner. So now we have additional buttons. Now we will refresh to hopefully be able to see this. And there we go. We got the test. We got the end turn. I'm also going to wrap any of these buttons in a padding. Wrap with padding, but we're just going to do only right of maybe like 6, just so that they get spaced out a little bit. 3 maybe. We'll call it 4. Awesome. So now we have these ways to have these buttons. Now I'm thinking in my head, we could probably actually refactor this so that even the end turn button is part of that, but I'm not going to worry about that because the end turn button is, going to be required in most games. So we'll just keep it kind of fixed, but this allows us in any game to actually have some additional buttons. So we will have a list of additional buttons right there. And the cool thing is we can override that in our 31 game provider. So override, I don't know why, additional buttons. And here we actually want to return an array, or list rather, of these things. And we're going to put a action button, and its label will be, I'll just call it knock. And on pressed will do something, but we'll get there in a bit. Okay, so at least now we have the option to sort of have this additional UI, and we will put it here. One more thing we should probably be keeping track of is, and we might have to refactor something for this, but let's do a final Boolean disabled, or actually we'll use enabled. And we'll do this dot enabled, and by default it'll be true. Okay, and that's fine. And then in our UI, discard pile, or game board rather, we can then pass over, I think there's a, on pressed. So on pressed, in order to enable or disable something, we can go button dot enabled, and that'll be the function that gets called, otherwise null. Okay, so we should see after I finish my turn, just to make sure this is working, which I will do, I can end my turn. Okay, so that button is still showing up. So we do need, right, because we have this here. This, I'm thinking like, yeah, we shouldn't ever show, we should not ever show these when, I'm thinking we can probably just move this up to the row itself, and kind of just change this. So what was it? Let me just undo. So what I can do is I can grab this guy, erase this, and put this at the row, and then do a question mark. And then at the end of the row, we can just do a container. So now if I end my turn, which I will do by just playing this, and end turn, there we go. Okay, so we have a knock, it goes away, and when it's my turn again, it shows back up. Okay, so let's figure out our knock functionality. I think with this, we can make use of our game state. So we have this button, and we're going to just do, we can go game state, and we can say, oh, hi Siri. Game state, we can, and let's go to our constants, and we'll make another one, const player has knocked. Remember, this is just a way that we can kind of have some keys on this generic stuff. And in fact, this shouldn't even be a constant necessarily in our main constants, because it really is just going to be specific to this game. So I'm going to put it here. Player has knocked, and we are calling it, we start them with GS just so we know what they are, and we'll just call it GS. I'm just going to make it the same thing. And this is just so if we're accessing this in multiple places, we will be less likely to make a typo. because working with strings is very easy to have a typo. And let's just try something here. I should be able to just go, like this could just be like set it to true or something like that. But I am going to try at least to use the current player. So turn dot current player. So we're actually going to track who is the one that knocked in theory. And then, yeah, so that's all good. If I click knock, I don't get any errors at least. So then what we want to do is, well, we want to set, that's one thing we want to do. We also then want to end the turn. So I think we can just go end turn, and let's just remember what that does. Because when you knock, you're also ending turn. Turn on next turn, bot will play if they can, etc., etc. So we'll just, let's see. So if I click knock, it does end my turn. This one plays. Now what we need to do is kind of have a way that, okay, at the game is over. Yeah, I think we can actually handle this in the game is over function, because when we can go if game state, and then we can use the game state player has knocked, does not equal null, and game state player is knocked. Actually, I think there's a, we'll just try it this way first, is equal to turn dot current player. And I'm just going to do something like print end, and we will return true. Otherwise, we will return false. Okay, so now this time if I click knock, it goes back, he still plays, and then game over. So we are pretty much there. So what we need to do now is we have a in our game provider, game is over. Oops, let's find where that is. Yeah, so we have something called finish game. So we can override that too. Let's just see what that actually looks like. And I'm just going to copy it over. And we need to make sure we copy this override as well. And this is where we would do our logic to count. So what we can do, and we'll make this simple at first, and then we have to make it a bit more complicated because of the way the rules work. So what we can do is for final p in turn dot players, or we can actually use players, they're going to be the same. For plea in players, we're going to do some stuff, and then we're going to make a variable. It'll be a integer called points. It's going to start with 0. Then we want to go for c in p dot cards, and for final c in p dot cards. Essentially, we want to count and give them a score. So there's probably a cleaner way to do this, but what we can do is, first of all, we have on a card a value. Now the value isn't an integer, it is a string. But what we can do is we can do a switch on c dot value. And we'll go case, and we'll do king, case queen, case jack. And in this case, if it's any of those, we're going to go points plus equals 10. That's how many points that person gets for each of those. Then we have a case for ace, and we have to break. Otherwise it will try and keep running through this. Points plus equals 11. Okay, then otherwise, so if none of those are true, we can run our default case here. Oh, we also need to break. And we can take whatever that value is. So you can go points plus equals c dot value. Now this won't work because this is a string. So now we have to actually parse it as an integer. This isn't the safest thing to do because who knows, maybe our API changes something. But for now, we should be good. We don't need a break after the default, so we're fine. So after we get through all their cards, we can then go and let's actually update our player model. just so we can keep track of this. And it's not going to be final. It's going to be something called points, or let's call it score. Int score, and we can go this dot score. It's going to equal to 0 when it goes. So we could, start the game with a higher score by passing it in, but otherwise it'll default to 0. Meaning now we should be able to go p after we've looped through all the cards, which is here. We can go p dot, and in fact, actually, why don't we do it this way? We should be able to just go p dot score instead of like kind of tracking it in a temporary variable. And then let's just go to the very end of this, and let's just do a print, and we'll do player. We'll do actually, let's do this. We'll do this part in the loop just for debugging purposes. So within the player's loop, at the very end of counting their cards, we will print p.name. What did I do wrong? I forgot that. p.name, and then we'll do p.score. So let's just see how this behaves. And I'll need to save that file too. And we'll refresh. And I am just going to knock right now just to get through this. And there we go. Tyler had 21, Bot had 22. And if you add these up, yep, that seems to check out my mind. Now, this isn't quite how the game works. It's not just what points you have, it's the points of each. You have to pick whatever suit is the most. So we are actually going to have to kind of go back to a slightly, we have to do this just a bit differently. So what I'm going to do is before we actually loop through the cards, let's just set a point for each suit. So we're going to make a int called points diamonds, or let's just call it diamond points. It's going to be equal to 0, and we're going to duplicate that 3 times. Spade points, club points, and heart points. Let's pluralize them. It sounds weird to say it that way. Okay, so now what we actually have to do is we will then make that variable we're talking about in int, and we'll just call it points, and it's gonna be equal to 0. And we're gonna actually go do points. So we're gonna add that variable. Then that's just in the switch case. So then at the end of the switch, but before we loop to the next one, we'll do another switch. So this is going to look a little bit messy. There might be a better way, but you'll get it when it's there. C.suit, and let's just do case suit dot clubs, sure. And so if the suit is clubs, we want to then take the spade, the clubs points plus equals points, right? Case suit dot diamonds, and we forgot our break. Diamonds points plus equals points. Case suit dot hearts, heart points plus equals points. And yes, we do need to put some breaks in. We'll get there. I'm on a roll. Suit dot, what do we have? Clubs, diamonds, hearts, spades. Spade points plus equals points. And then we'll do default, and we're just gonna not do anything in there. Can I pass? No. Okay, break. Okay, then now that we have that, so we've looped through all these, and we want to make sure that in this part here, so after we loop through all the cards and essentially incremented them, we want to find out which one's the most. So I'm going to, just to see if this even works, let's just kind of like do spade Oops. Oh, I don't know what's happening. Spade points. Is this not in the, where's the loop that we're in cards, in players? Am I in the wrong spot? No, I'm here. I just spelled it wrong. Spades, hearts points, diamonds points, and clubs points. Spades, hearts. Let's just see if this logic actually works before we figure out how to assign it. And okay, refresh game. And new game, knock. Just knock it right away. And okay, so we see now this is happening for both players. So 0, 16, 0, 8. That's probably me. Yeah, 8 for the clubs, 16 for hearts, 0 for the other one. So that is working. What we need to do is find out what the max is. Now, we're not just going to be like adding these together because you only get the one for the most. So we're actually going to make a list of all these things. Spade points, heart points, diamond points, and club points. So we just kind of have a list of all these. And then we can do what's called a fold. So fold's a way that you can, and I sort of have the stuff up here. And we take the initial value is going to be spade points. Oh, wait. And then I think we just pass in the word. Where does max come from? The Dart math library. Yeah, we have to import from math. And we can just pass in the function. So this should print total points. What happened here? Oh, I put this in the wrong spot. So we should be able to just go p dot score is equal to total points. And then let's just see if that works. I'm going to get rid of these guys. Print total points. And let's just make sure we're good. I'm going to restart. New game. And this, if I knock now, and in fact, yeah, no, this is perfect. This is perfect. So let's knock. Bot goes, and it's telling me one of us has 17 and one of us has 15. Now 8 plus 7 is 17, and yeah, spades 15. So there you go. There's your logic to determine who the winner is. Now, a little bit of tidy up here we'd have to do. We obviously want to like actually end the game, and set these points and do like, hey, this person's the winner. But we basically have the logic here. We could play for a long time and I could try and get 31. Let's see. So I'm not gonna pick that up. I'm gonna go blind and I'm gonna discard. I have a lot of clubs now, so let's discard that and I'll end my turn. Let's see how close we can get. That card, it's slightly helpful. Let's grab it and end turn. 7. I'm getting a lot of clubs, but nothing that much better. End turn, and let's just. So I can see they have the queen of clubs. They don't have any strategy, so I'm not worried. I might get that. So let's just kind of go through this quickly. Oh yeah, the order. Eventually, I will get that queen of clubs, knowing that the bot has some really good rolls. So we'll very quickly, just finish this up. End turn, and I should get the queen of clubs now. So I'll grab that, and I'll get rid of my 8. End turn. And I'm gonna call this and say knock. And we'll see here I got 30 points, almost the max 31 and everything. So yeah, that's kind of it. Like have fun, make your own games. I hope you learned a lot. about just, making a Flutter app.